Tony has 2/3 of a bag of dark chocolate chips and 4/5 of a bag of white chocolate chips. Determine a reasonable estimate of the total amount of chocolate chips Tony has. So pause this video and see if you can figure out which of these choices is the best reasonable estimate of the total amount of chocolate chips. Alright, now let's work on this together. Now in the future, we will learn how to actually add something like 2/3 to 4/5, but for the sake of this exercise, we just want to get good at estimating. And one way to estimate is to try to visualize. So so this is a hole right over here, and then this is another hole right over there. I'm trying to make them the same size. Now what does 2/3 look like? Well, let me divide this into 3 equal sections, so that's pretty close. It's hand-drawn, so it's not perfect, but I think it gets the job done. And 2/3 would be, that's 1/3 right over there, and then that is 2/3 right there. And what does 4/5 look like? Well, let's see, I can divide this into fifths, so 1/5, 2/5, 3/5, and then 4/5 and 5/5. That is pretty good. And now what does 4/5 look like? Well, it would be 1/5, 2/5, 3/5, and then 4/5. So if we were to add these two together, do we have less than 1/2 of a bag, more than 1/2 of a bag, but less than 1 bag, or more than 1 bag? Well, when you see even the first 2/3, where is a half? A half would have been right around there, if we're talking about half of it. So 2/3 is more than a half. And then we also see that 4/5 is more than a half. If you had a half, it would have been like this far. So you can see that you're adding two things together that are both more than a half. And if you have 2 halves of something, that would be a whole. So if you have 2 things that are more than a half, if you add them together, you're going to have more than a bag of chocolate chips. So I like this choice right over here. Let's do another example. So here we are told that a banana weighs 3/8 of a kilogram, an apple weighs 2/3 of a kilogram. Determine a reasonable estimate for the weight of both fruits. So pause this video again and see if you can have a go at that. Alright, so the key is that we need to determine a reasonable estimate. So let's actually just try to represent these again. So how could I represent 3/8 of something, of a kilogram in this case? Well, let me draw a rectangle here, and I'm going to try to divide it into 8s, 8 equal sections. So that looks about a half. I'm doing it right over there. That looks like about a half. And then if I were to divide those, these would be 4ths. And this is hand-drawn, so it's not perfect, but it will help us understand things a bit. So then let me divide these. So this would get me to 8ths. So I have 8 sections here. 1, 2, 3, 4, 5, 6, 7, 8. If I'm talking about 3 of those 8 equal sections, I'd have 1/8, 2/8, and 3/8. So that is 3/8 right over there. And what does 2/3 look like? So I'll do that in purple. So if this is a hole, this is a hole like that. If I divide it into 3 equal sections, it's going to be something like that. I can draw it a little bit better. So something like that. And so 2 of those 3 equal sections, that's 1/3, and so that is 2/3. Now what happens if I try to add these things together? Well, one thing I could try to do to help visualize is I could take that piece there. The holes are roughly the same length, or I try to draw them so that they're roughly the same length. And if I were to copy and paste that and then move that over here, it looks like, if I were to estimate it, I'm getting pretty close to a whole kilogram here. So it's definitely not just about 1/3 of a kilogram. 1/3 of a kilogram would be just one of these 3 equal sections. We're way more than that, so we ruled that out. About 1 kilogram, that's what we saw. When we take the 2/3 and add to that 3/8, where it looks like, and once again, we're estimating, we don't know exactly, it looks like we're a little bit over a kilogram. So I like this choice. And we're nowhere close to 2 kilograms. 2 kilograms would be filling in another hole on top of this one right over here. So it's not that choice either.
We're asked to rewrite the following 2 fractions as fractions with a least common denominator. Least common denominator. So a least common denominator for 2 fractions is really just going to be the least common multiple of both of these denominators over here. And the value of doing that is then if you can make these a common denominator, then you can add the 2 fractions, and we'll see that in other videos. But first of all, let's just find the least common multiple. So the least common, let me write it out because sometimes LCD can mean other things. So least common denominator of these 2 things is going to be the same thing as the least common multiple of the 2 denominators over here. The least common multiple of 8 and 6. And a couple of ways to think about least common multiple. You literally could just take the multiples of 8 and 6 and see what their smallest common multiple is. So let's do it that way first. So multiples of 6 are 6, 12, 18, 24, 30, and I could keep going if we don't find any common multiples in this this group here with any of the multiples of 8. And the multiples of 8 are 8, 16, 24, it looks like we're done, and we can keep going, obviously, 32, so on and so forth. But I found a common multiple, and this is their smallest common multiple. They have other common multiples, 48, and 72, and we can keep adding more and more multiples, but this is their smallest common multiple, their least common multiple. So it is 24. Another way that you could have found that least common multiple is you could have taken the prime factorization of 6. You say, hey, that's 2 and 3. So anything that is the least common multiple has to have at least 1, 2, and 1, 3 in its prime factorization in order for it to be divisible by 6. And you could have said, what's the prime factorization of 8? It is 2 times 4, and 4 is 2 times 2. So in order to be divisible by 8, you have to have at least 3 2's in the prime factorization. So to be divisible by 6, you have to have a 2 times a 3. And then to be divisible by 8, you have to have at least 3 2's. We only have, or you have to have 2 times itself 3 times, I should say. But we have 1 2. Now let's throw in a couple more. So then you'll have another 2, and then another 2. So this part right over here makes it divisible by 8, and this part right over here makes it divisible by 6. If I take 2 times 2 times 2 times 3, that does give me 24. That gives me 24. So our least common multiple of 8 and 6, which is also the least common denominator of these two fractions, is going to be 24. So what we want to do is rewrite each of these fractions with 24 as the denominator. So I'll start with 2 over 8. And I want to write that as something over 24. I want to write that as something over 24. Well, to get the denominator to be 24, we have to multiply it by 3. 8 times 3 is 24. And so if we don't want to change the value of the fraction, we have to multiply the numerator and the denominator by the same thing. So let's multiply the numerator by 3 as well. 2 times 3 is 6. So 2 eighths is the exact same thing as 6 24ths. To see that a little bit clearer, you say, look, if I have 2 eighths, and if I multiply this times 3 over 3, that gives me 6 over 24. And this are the same fraction, because 3 over 3 is really just 1. It's 1 whole. So 2 eighths is 6 24ths, and let's do the same thing with 5 6. 5 6. So 5 over 6 is equal to something over 24. Let me do that in a different color. I'll do it in blue. Something over 24. To get the denominator from 6 to 24, we have to multiply it by 4. So if we don't want to change the value of 5 6, we have to multiply the numerator and the denominator by the same thing. So let's multiply the numerator times 4. 5 times 4 is 20. 5 6 is the same thing as 20 24ths. So we're done. We've written 2 eighths as 6 24ths, and we've written 5 6 as 20 24ths. If we wanted to add them now, we could literally just add 6 24ths to 20 24ths. And I'll leave you there because they didn't ask us to actually do that.
So in this video, we're going to think about dividing numbers where the quotient, the result of our division, might result in a decimal. So let's say we wanted to compute what 5 divided by 2 is. In the past, you might have said, hey, 2 times 2 is 4, and then you have 1 left over, and so you might have said something like this. This is 2 with a remainder of 1. But now we don't want to just say, hey, how many times can it go in and what's left over? We want to know exactly how many times can 2 go into 5. So we want a decimal answer right over here. So pause this video and see if you can figure that out. Alright, now let's work through this together. And there's many ways that we can approach this. One way is to realize that 5 divided by 2, we can re-express as 5 divided by 2, or as 5 halves. And 5 halves is the same thing as 4 plus 1 over 2, which is the same thing as 4 halves plus 1 half, which is the same thing as 4 halves is 2. Let me do that in a different color. This part over here is 2, and then you have this 1 half. So it's the same thing as 2 and a half. And if we were to express that as a decimal, that's going to be equal to 2 and how many tenths is equal to a half? Well, 5 tenths is equal to a half. So 5 divided by 2, you could say, is 2.5. Now, another way that you could approach this is you say 5 divided by 2 is the same thing as 50 tenths divided by 2. So let me use a different color here. So instead of a 5, I could say 5 is the same thing as 50 tenths divided by 2. And so if I have 50 of something, and if I were to divide it by 2, well, that's going to result in 25 of the something. So this is going to be equal to 25 tenths. And how would we express 25 tenths as a decimal? Well, this is going to be equal to, I could put some place values here. So we definitely have 5 tenths. I'll put that in the tenths place. And then 20 tenths. 20 tenths is the same thing as 2 ones. And that's exactly what we had up here. Either way, you get 2.5, 2 ones and 5 tenths. Let's say we want to figure out what 8 divided by 4 tenths is. Pause this video and try to figure it out on your own before we do it together. Alright, now one way to approach this is to think about everything in terms of tenths. And why tenths, you ask? Well, I just described the second number as 4 tenths. So what would 8 be in terms of tenths? Well, we know that 1 whole is equal to 10 tenths. So 8 wholes is going to be equal to 80 tenths. So I could write that down over here. Instead of 8, I can write that as 80 tenths. And I'm taking 80 tenths and I'm divided by 4 tenths. I'm just writing it out. 4 tenths. So if I have 80 of something, and if I'm dividing it into groups of 4 of that something, how many equal groups am I going to have? Well, I'm going to have 80 divided by 4 groups, or 80 divided by 4, 8 divided by 4. Actually, let me just write that down. This is going to be equal to 80 over 4, or 80 divided by 4. And 8 divided by 4 is 2, so 80 divided by 4 is going to be equal to 20. So 8 divided by 4/10 is equal to 20. Another way that you could think about that is to rewrite 8 divided by 4/10 as 8 over 4/10 over 4/10. And then if you wanted to rewrite this, you could say, hey, can I multiply the numerator and the denominator by some quantity that'll get rid of the decimal in the denominator? Well, I could multiply the denominator by 10, and if I don't want to change the value of the fraction, I have to multiply the numerator by that same amount. Well, what does that get us? Well, this is going to be equal to, in the denominator right over here, I'm just going to have a 4, so we got rid of the decimal, and the numerator, I am going to get 80. So once again, we get 80 over 4, which is equal to 20. Let's do another example, but in this case, we'll deal with hundredths. So let's say we want to figure out what is 48 divided by 0.24, or 24 hundredths. Pause this video and try to figure that out. Alright, well we can do something very similar. This time we're dealing with hundredths, so we could try to express everything in terms of hundredths. So 48 is equal to how many hundredths? Well, we know that 1 is equal to 100 hundredths. So 48 is going to be equal to 48 times 100 hundredths. And maybe I'll just write it like that. Or you might be able to say, hey, that's 4,800 or 4,800 hundredths. So let's just, actually I'll write it that way. This is going to be 4,800 hundredths divided by, this is 24 hundredths. 24 hundredths. And so what's that going to be? Well, same logic as we used up here. If I have 4,800 of something, or 4,800 of something, and if I'm dividing it into equal groups of 24 of that something, well, I'm going to have 4,800 divided by 24 equal groups. So this is going to be equal to 4,800 over 24. We could express 4,800 as, of course, 48 times 100. So this is equal to 48 times 100 over 24. And, of course, you could view this as the same thing as, this is equal to 48 over 24. 48 over 24, and many of you might have already done it in your head, times 100. What's 48 divided by 24? Well, that is going to be equal to 2. So 2 times 100 is equal to 200. So this right over here is equal to 200. You could also do it in this type, or do it similar to the way we did this, where instead of expressing it out as words, you could express it as 48 over 24 hundredths. And instead of multiplying the numerator and denominator by 10, maybe you want to multiply it by something else to get whole numbers in both the numerator and denominator. Think about that after this video and try to work it out that way as well. In this video, we're going to come up with some strategies for division when the quotient isn't a whole number, when it's going to be a decimal. So let's try to compute 3 divided by 2. Pause the video and see if you can figure out what that is going to be. And I'll give you a hint, it's not going to be a whole number. Alright, now let's try to work this together. And like all things in mathematics, there's multiple strategies that you can use to try to figure out what 3 divided by 2 is. One strategy is, well, let's just rewrite this as a fraction. So 3 divided by 2, you could write that as 3 over 2. Now, or you could say this is the same thing as 3 halves. But how can we express this as a decimal? Well, you might recognize that 3 halves is the same thing as 2 halves plus 1 half. Let me write that down. So this is the same thing as 2 plus 1 over 2. And I'm really doing every step here to hopefully make things clear, which is the same thing as 2 over 2. So that's 2 over 2 plus 1 over 2 plus 1 half. I could break this up into 2 over 2 plus 1 half. Now 2 over 2 is just 1. And so this is going to be equal to 1 and 1 half. Now, you might immediately say, hey, a half, I could write that as 5/10, and that would be exactly right. You could just, if we want to spell out every step, we could say this is equal to 1, and since when we write it in decimal form, we express things as tenths or hundredths or thousandths, so 1 half is the same thing as 5/10, and if we wanted to express that as a decimal, this would be equal to 1 and 5/10. 1 and 5/10. Now, I did every step here. As you get more practice, you say, okay, this is the same thing as 3 halves. 3 halves, 2 goes into 3 one time, and there's a half left over. So writing this as a mixed number, it's 1 1/2. And a half, written as a decimal, is 5/10. So this is 1 and 5/10. Now, another way that we could have thought about this is, okay, I'm not getting a whole number when I divide 3 divided by 2. Maybe I'll get something in terms of tenths. So let me express each of these in terms of tenths. So 3 is how many tenths? Well, 3 is 30 tenths. 30 tenths, and we'd be dividing by 2, we're going to be dividing it by 2. So 30 tenths divided by 2, well, that's going to be equal to 15 tenths. This is equal to 15 tenths, which is equal to 10 tenths and 5 tenths, or 1 and 5 tenths. So both of these are equally legitimate strategies for figuring out what 3 divided by 2 is. I like the first one a little bit. It leverages what we know about fractions. But let's do another example. Let's do a few more examples. This is fun. All right, let's figure out what 34 divided by 4 is. Divided by 4. And like before, pause this video and try to figure it out and try to see if you can use some of the strategies that we used in the last video. All right, so as we just said, we could re-express this as a fraction. This is the same thing as 34 divided by 4. 34 divided by 4. Or 34 fourths. Now what is this going to be equal to? Well, 4 goes into 34 8 times. So it's going to go 8 times. And you're going to have 2 left over. So this is 8 and 2 fourths. 8. Actually, let me write it. Well, all right. 8 and 2 fourths. Do that 2 in that blue just for fun. 8 and 2 over 4. 8 and 2 fourths. So how do I do this again? I said 4 goes into 34 8 times, and then I have 2 left over, so I'm going to have 2 fourths left over. Another way, if you want to see all the steps, you could say, hey, I could rewrite this as 32 over 4 plus 2 over 4. The 32 over 4 is our 8, so 8 and 2 fourths. Well, 2 fourths, that's the same thing as 1/2. That's the same thing as 1/2. And if we want to express that in terms of tenths, this is equal to 8, and 1/2 is the same thing as 5 tenths. 8 and 5 tenths, which if we want to express it as a decimal is, of course, 8 and 5 tenths, or 8.5. And we are done. Let's do another one of these. And actually, let's do one of them where we are dividing into a decimal, where a decimal itself is being divided. So let's say we wanted to calculate 8.4 divided by 7. Pause this video and see if you can figure it out. So when you look at this, you might immediately say, well, okay, I know 84 is divisible by 7. We know, if you know your 7 times tables, we know that 7 times 12 is equal to 84, or that 84 divided by 7 is equal to 12. But this isn't 84, this is 8.4. So how do we think about it? Well, one way is we could think about it in terms of tenths. 8.4 is the same thing as 84 tenths. And so 84 tenths divided by 7. Well, 84 of anything divided by 7 is going to be 12 of that thing. So it's going to be 12 tenths. And 12 tenths we can rewrite as 1 and 2 tenths, or 1.2. 1.2. And we are done. So this is equal to 1.2. Another way that we could have thought about this is we could have said, you know what, 84 tenths is the same thing as 84 over 10. In fact, you would read this as 84 tenths. And now you want to divide this by 7. So you want to divide this by 7. This is the same thing. When you divide by something, it's the same as multiplying by the reciprocal. So it's 84 over 10 times 1/7 times 1/7, which is equal to, we can change, well, let me write it this way. This is equal to 84 over 10 times 7, over 10 times 7. And now we could simplify this. If we divide the numerator and the denominator by 7, 84 divided by 7 is 12, 7 divided by 7 is 1, 12 divided by 10, this is going to be equal to 12 tenths, which is 1.2. We could write this as 1 and 2 tenths, or 1.2. Let's do one more example that's kind of related. Let's say we want to figure out what 7 divided by 70 is. Pause this video and try to figure it out. Well, we can rewrite this, as we've been doing, as 7 over 70. Instead of writing it as 70, let me write that as 7 times 10. And what's valuable about this is we can divide the numerator and the denominator by 7. If we divide the numerator by 7, we get a 1. We divide the denominator by 7, we get a 1. Remember, we can do the same thing to the numerator and denominator. If we multiply or divide by the same value, we're not changing the value of the actual fraction. And so you're left with 1/10, which if you express it as a decimal, you go to the tenths place, you say, hey, I have one of those tenths. That's 1/10. So this is 1/10. Another way to think about it is, this is the same thing as, and really this is what we wrote over here, but you could write this as 7 divided by 7, divided by the blue 7, and then you divide by 10. If you're dividing by 7 times 10, we're dividing, actually, let me write that down. If you're dividing by 7 times 10, and this is essentially another way of writing what we have over here, this is going to be equal to 7 divided by 7 divided by 10. Divided by 10. Well, 7 divided by 7 is 1, so you get 1 divided by 10, which is 1/10, 1/10. what we're going to do in this video is get a little bit of practice estimating dividing with decimals. So for example, we want to figure out approximately, that's what these kind of squiggly equal sign means. This means approximately equal. So what is 80 divided by 1.94 approximately equal? So we want to estimate what this is. So pause this video and see if you can figure it out. So before we even look at these choices, how would we try to do this in our head? Well, we could say 1.94, it's hard to do that in our head, to divide it into 80, but it's awfully close to 2. So we could say this is close to, this is approximately equal to 80 divided by 2, because once again, 1.94 is awfully close to 2, and then this is easy to figure out. That is going to be equal to 40. So our first expression, you could say, is approximately equal to 40. Is it exactly equal to 40? No, but it's pretty close, so I would select that choice. Let's do another one. So pause this video and see if you can figure out the approximation. What is 209 divided by 3 roughly equal to? So once again, here we don't have any clear decimals. If we were to divide it out, we would get a decimal answer for our quotient. But what we could do is, well, is either one of these, is for example, 209, is it close to a multiple of 3 that we might recognize? Well, you might immediately recognize that, well, if you think about multiples of 3, you think in terms of, well, 3 times 6 is 18, 3 times 7 is 21. Well, this is close to 210. So this is approximately equal to 210 divided by 3. Now, why is this interesting? Well, 210 is just 21 times 10. So if 21 divided by 3 is 7, 210 divided by 3 is going to be equal to 70. So once again, 209 is pretty close to 210. Remember, we're just estimating. And so 209 divided by 3 would approximately be equal to 70, which is that choice right over there. Let's do one more example. So once again, pause the video and figure out what 6.86 divided by 1.12 is approximately equal to. Alright, so here, I would just try to round to the nearest whole number and see if that helps my division in my head. So 6.86 is approximately 7 if we round up to the nearest whole number. And if I say 7 divided by, and if we round down 1.12, 7 divided by 1, this is much easier for us to do in our head. So that is going to be 7. Now, once again, it's very important to realize these are estimations. It's not going to be exactly equal to 7, but it's definitely going to be much closer to 7 than 7,700 or 7,000. Let's see if we can compute what 1.86 divided by 2 is. And like always, pause this video and have a go at it, and I'll give you a hint. See if you can think about 1.86 as a certain number of hundredths, and then divide that by 2. Alright, now let's work through it together. So as promised, let's see if we can think of 1.86 as a certain number of hundredths. So if we go to the hundredths place, we only see 6 there, but we could view 8 tenths as 80 hundredths. So you could view the 0.86 as 86 hundredths, and each one is 100 hundredths. So we really have 186 hundredths. So this number right over here, I'm going to rewrite as 186 hundredths. Hundredths. And that is what we need to divide by 2. Now, if you're dividing 186 of something by 2, well, it's just going to be 186 divided by 2 of that something. So we could rewrite this as 186 divided by 2. And then that's the number of hundredths this is going to be. So I'll put that in parentheses. So it's going to be that many hundredths. Hundredths. All right. So what is 186 divided by 2? Some of you might be able to do it in your head. Some of you might want to use some paper. The way I like to think about it is, if I were to take the 6 ones and divide it by 2, well, that's going to be 3 ones. And then if I were to take the 18 tens and divide it by 2, that's going to be 9 tens. So that gets us to 93. Now, you could have also thought about it like this. You could have said, how many times does 2 go into 186? Let's see, it doesn't go into 1. How many times does it go into 18? 9 times. 9 times 2 is 18. We could subtract, and then you have 0. You bring down that 6. 2 goes into 6 3 times. 3 times 2 is 6. You subtract, and you get no remainder. So either way, you're going to get 93. And it's 93 what? What's 93 hundredths is what we're talking about. 93 hundredths. And now we just want to express 93 hundredths as a decimal. Well, how do we do that? Well, that's going to be 0. The 90 hundredths is the same thing as 9 tenths. And then the 3 hundredths is, of course, 3 hundredths. 3 in the hundredths place. So it's 0.93. So we could write it up here. This is going to be equal to 0.93. And we're done.
In this video, we're going to try to figure out what 4 tenths divided by 5 is. So pause this video and see if you can think about it before we work through it together. We're really going to think about approaching this visually. Alright, now let's work through this together, and let's actually try to think about what 4 tenths looks like. So if you view this entire square as a whole, you see that we've divided into 10 equal columns or 10 equal sections, and 4 of those tenths are shaded in. So what you see here in blue is 4 tenths. But how do we divide that into 5 and make sense of it? Well, one way to think about it is to imagine 4/10 not just as 4/10, but to imagine it as 40 hundredths. So this would be imagining it as 40 hundredths. So we can rewrite 4/10 divided by 5 as 40 hundredths divided by 5. And now we could think about taking these 40 hundredths, each of these little squares is a hundredth, and divide it into 5 equal sections. And then we could say, well, how many hundredths are in each of those 5 equal sections? So let's do that. So let's see, this is 1, this is 2, this is 3, this is 4, and then we have 5 equal sections. So how many hundredths are in each of those equal sections? Well, we can see in each of them you have 1, 2, 3, 4, 5, 6, 7, 8. So 40 hundredths divided by 5 is going to be 8 hundredths, because we have 8 of these little squares in each of those 5 equal sections. So 8 hundredths we would write like this. And so 40 hundredths divided by 5 is 8 hundredths. Then 4/10 divided by 5 is also equal to 8 hundredths. So in this video, we're going to try to think of ways to compute what 31.2 times 19 is. And there's multiple ways to approach this, but like always, try to pause this video and see if you can work through this on your own. All right, now let's do this together. Now one way to think about this is you could view 31.2 as a certain number of tenths. And how many tenths would this be? Well, you could view this 31.2 as 312 tenths. And so this is the same thing as 312 tenths times 19. And so what we could do is we could figure out what is 312 of something times 19, or what's 312 times 19. And it's going to be that many tenths, and then we could convert it back to a decimal. I'll also show another strategy, but let's just do that. So if we were to just multiply 312 times 19, this is going to be, let's see, 2, this is another color, 2 times 9 is 18, 1 times 9 is 9, plus 1 is 10, 3 times 9 is 27, plus 1 is 28. If what I just did looks unfamiliar, we have videos that explain how this process works. And then we go to the tens place right over here. And so we would say 1 times 2 is 2, 1 times 1 is 1, 1 times 3 is 3. And then we add everything together, we get 8. 0 plus 2 is 2, 8 plus 1 is 9, 2 plus 3 is 5. So we get 5928, or 5,928. Now that's not going to be the answer here. The answer is going to be 5,928 tenths. So this is going to be equal to 5,928 tenths. Now, how can we express this as a decimal? Well, we can think of it this way. If that's the decimal, this is the tenths place. This is the ones place, which is the same. This is the same thing as 10 tenths place, which is the ones place. This is the tens place, and this is the hundreds place. Well, you have 8 tenths. We can put that in the tenths place. You have these 20 tenths. That's the same thing as 2 ones. You have the 900 tenths in a different color. 900 tenths is the same thing as 9 tens. And then your 5,000 tenths is the same thing as 5 hundreds. Another way to think about it is, we wrote all the places out, and we wrote it in terms of tenths. So the 8 went there, and then every place to the left of that went to the place to the left of that. So this is going to be 592 and 8 tenths. So we could write it like that, 592 and 8 tenths. Now, another way to approach this is to just think about the digits, not the actual numbers, to figure out, well, the answer will have what digits in it, and then try to estimate to think about where the decimal place should go. So, for example, you could do 312 times 19. So essentially remove the decimal, do the computation, and say, okay, the answer should have the digits 5, 9, 2, 8 in that order. Now, where should I put the decimal in order for that to be a reasonable answer? And that's where estimation comes in. You could say, hey, 31.2 times 19, that's going to be approximately equal to, if I try to estimate these with numbers that are easy to multiply, that's going to be roughly equal to 30 times 20, which is equal to 600. So that tells me that my product here should be roughly equal to 600. And so where would I put the decimal here for it to be roughly equal to 600? So I know the answer has the digits 5, 9, 2, 8. Where do I put a decimal for it to be roughly equal to 600? Well, if I were to put the decimal there, that's not roughly equal to 600. If I were to put the decimal there, that's not roughly equal to 600. That's close to 60. If I put the decimal there, that's close to 6. If I want to be close to 600, I'd have to put the decimal right over there. And so that's also a good way to test the reasonableness of what's going on. This should be roughly equal to 600 if we were to estimate it. And so we like that our process got an answer that is roughly equal to 600.
We are asked to estimate what is 2.7 times 4 roughly equal to. Pause this video and see if you can answer that. All right, so we could think of 2.7 times 4 as being roughly equal to, or some people might say as approximately equal to. Well, let's see, 2.7, that's 2 ones and 7 tenths. We could think about, well, what's the nearest whole number to 2.7? And so 2.7 is pretty close to 3. It's in fact closer to 3 than it is to 2. So we could say that this is roughly equal to 3 times 4. And then 3 times 4 is, of course, equal to 12. And you can see that these other answers actually seem quite unreasonable. 1.2, if I take something and I multiply it times 4, I shouldn't get an answer that is less than my original something. And then to take something that's roughly equal to 3 times 4 to get to 120, that doesn't make sense, and definitely doesn't make sense to get to 1200. Let's do another example. So here where we said, what is roughly equal to 78 times 19.88? So pause this video and try to answer that. All right, well, it's really the same idea. We want to think about, well, what are numbers that these numbers are close to that are easy to multiply with? So for example, 78, that is pretty close to 80. And then 19.88 or 19 and 88 hundredths, that's pretty close to 20. It's closer to 20 than it is to 19. And even if it was closer to 19, just to estimate, I probably would still go to 20 because it's easier to multiply with 20. So this is going to be pretty close to 20. So all of this is going to be roughly equal to 80 times 20. And you might already recognize that this is going to be 8 times 2 times 10 times 10. And I could write it that way. Actually, no reason for me to skip steps. But you would normally do this in your head. So 80 is the same thing as 8 times 10. Let me do that in that purple color so you can see it. So this is the same thing as 8 times 10 times 2 times 10, which we could then write. This is going to be 8 times 2, which is 16. So the 8 and the 2, you get 16 times 10 times 10 is times 100. So this should be 1600. 1600, which is this choice right over here. And it's always good to just do a reality check to make sure it's reasonable. It wouldn't make any sense if I take a number close to 80 and I multiply it times some number that is close to 20 and get a smaller number than 80. It also, if you have a number that's close to 80, to get 160, you'd only have to multiply it by roughly 2. But here we're multiplying by roughly 20. And then to go from 80 to, or roughly 80, to 16,000, well, then you wouldn't have to multiply by something that's close to 20. You'd have to multiply something that's close to 200. So I like our answer.
So what we have here on this number line that we've now marked off with the tenths, and you can see that this is 3 tenths here, we can think about this as a multiplication of a decimal. And so what is this representing? And I'll give you a hint. It's representing something times 3 tenths. So pause the video and try to think about that. Well, let's see. We are going 1 times 3 tenths, 2 times 3 tenths, 3 times 3 tenths, and then 4 times 3 tenths. So what's represented here is 4 times 3 tenths. And so what is this going to be equal to? Well, you can see, you go from 3 tenths to 6 tenths to 9 tenths, and then you could do this as 12 tenths, but 12 tenths is the same thing as 1 and 2 tenths. So you could do this as 1.2, 1 and 2 tenths. Let's do another example. Now, actually, I'll do it on the same number line. If we wanted to represent 3 times 0.2, what would that look like on this number line, and what would this be equal to? So I'll put an equal sign here. Pause this video and see if you can figure that out. Alright, so let's think about where 2 tenths is. This is 1 tenth, 2 tenths is right over there. This is 0.2. And we're going to multiply it times 3. So we're going to multiply it times 1. Then we're going to multiply it times 2. That takes us to 4 tenths. Then we're going to multiply it times 3 to get us to 6 tenths, 0.6. So it's 6 tenths, just like that. Now you can also visualize 2 tenths as parts of a whole. So for example, this represents 2 tenths. I have this whole, this square is a whole. It's split into 10 equal columns here, and we have 2 of them filled in, so this represents 2 tenths. So if you have 3 times 2 tenths, well, this is 1 times 2 tenths, this is 2 times 2 tenths, and this is 3 times 2 tenths. And so how many tenths do we now have? Well, we have 1, 2, 3, 4, 5, 6 tenths, which is exactly what we have here, 6 tenths. Let's do one more example that gets a little bit more involved. So here we're told to multiply. It says you may use the model shown to help find the product. And this is a screenshot from the exercise on Khan Academy. So pause this video and see if you can figure out what this is. All right, so they're saying 52 hundredths times 3, and they have 52 hundredths depicted right over here, and then they have it depicted 3 times. So the total number of hundredths depicted here, that is 52 hundredths times 3, because we have 52 hundredths here, another 52 hundredths, and then another 52 hundredths. So how many hundredths is that going to be? Well, you could view this as 52 times 3, and that will give you the number of hundredths we have. So let's think about this. So if we were to just say 52 times 3, Well, this is going to be 2 times 3 is equal to 6, and then 5 tens times 3 is 15 tens, which is the same thing. We can either just write it as 15 tens, or that's 105 tens. But either way, if I have 52 of something and I multiply that by 3, I now have 156 of that something. And here, the something is hundredths. So if I say 52 hundredths times 3, that's going to be 156 hundredths. And how do we represent 156 hundredths? Well, there's a couple of ways to think about it. If this is the ones place, this is the tenths place, this is the hundredths place, well, we would write the 6 there, the 5 there, and the 1 there. So you could recognize this as, hey, look, 100 hundredths, let me color code it, 100 hundredths is the same thing as a whole, and I'll circle that in red, and 50 hundredths is the same thing as 5 tenths, and of course 6 hundredths is the same thing as 6 hundredths. So this is going to be equal to, we can say 1.56, or you can view this as 156 hundredths, so you can view this as a whole, which is 100 hundredths, and 5 tenths, which is 50 hundredths, and 6 hundredths.
What we're going to do in this video is get some practice estimating adding decimals. So here it says 12.93 plus 6.1 is approximately equal to, this little squiggly equal sign means approximately equal to. So try to estimate this and pick the right choice. So pause the video and try to do that. All right, now let's work through this together. So we could work this out by hand, but the whole goal here is estimation. And so if I were doing this in my head, I'd say, well, look, 12.93 is a little bit less than 13, and 6.1 is a little bit more than 6. And it's actually nice because when I rounded, I went down on this number and I went up on this number. So I went up 7 hundredths to get to 13, and I went down a tenth to get to 6. So I feel good when I add them up that we're going to get pretty close to the actual answer. So 13 plus 6 is equal to 19, and lucky for us that that is one of the choices. And there's multiple ways that you could try to estimate things. For example, you could do a little finer of an estimation. You'd say this is approximately 12.9 plus 6.1, and then you say 12 plus 6 is 18, and then 9 tenths plus 1 tenth is another 1. So you'd say this is 18 plus 1, and you say, okay, that once again gets me pretty close to 19, or this gets me to 19. Let's do another example. So here we're told 5 plus 1 plus 4.91 is approximately equal to what? So pause this video and see if you can figure that out. Try to estimate it. Try to do it without any paper. Well, the way I would do it is actually very similar to the way we just did the last one. Well, 5.1 is approximately equal to 5, and it's approximately equal to 5, and 4.91 is also approximately equal to 5. I rounded to the nearest whole number in either case, and so that would be equal to 10. And once again, it makes sense because we rounded down here and we rounded up here. We rounded down to go from 5.1 to 5, and we rounded up to go from 4.91 to 5. If you're rounding down in both cases or rounding up in both cases, your estimate might get a little bit further from your actual answer, so you might want to be a little bit careful. All right, so in this last example, once again, pause the video and see if you can work through it on your own. Well, we're just going to do the same thing here. This is going to be approximately equal to 3 plus, I rounded down, 3.14, rounded to the nearest whole number is 3. 5.92 rounded to the nearest whole number is 6. And once again, just like I mentioned in the previous ones, this is good because I'm rounding down from 3.14 to 3. I took away 14 hundredths, and then I add 8 hundredths to 5.92. So it's going to get me reasonably close to the actual answer. And so 3 plus 6 is equal to 9, which is indeed one of the answers here. And this is actually interesting. You're not always going to see a multiple choice if you're trying to estimate things, but in this case, you know that just 3 plus 5 is going to be 8, and so this can't be the choice. And then you're going to have 8 plus whatever 14 hundredths plus 92 hundredths is, and you know that's more than 1, so you know our answer is going to be a little bit over 9. So once again, 9 is a good approximation. In this video, we're going to introduce ourselves to the idea of adding decimals. And I encourage you, as we work through these problems, to keep pausing the video and seeing if you can think about it on your own before we work through it together. Now we're going to build up slowly, and in future videos, we're going to find out faster ways of doing it. But the way we're learning it in this video and the next few is to really make sure we understand what is happening. So let's say we wanted to add 0.1 to 0.8, or you could say we're adding 1/10 to 8 tenths. Pause this video and see if you can figure that out. Well, there's a couple of ways to think about it. You could say, hey look, 0.1, that is 1 tenth, and 0.8, that is 8 tenths. And so if I have 1 of something and I add 8 more of that something, so I have 1 tenth and I'm going to add 8 more tenths, well, I'm going to end up with 9 of that something. In this case, we're talking about tenths. So that is going to be equal to 9 tenths. That's one way to think about it. Another way, we could think about it visually. So let's say we take a whole and we were to divide it into tenths, which we have right over here. So if we say this whole square is a whole, we divide it into 10 equal sections. So each of these white bars you can view as a tenth. So we have 1 tenth. So let me fill that in. So 1 tenth. Whoops, that's not what I wanted to do. We have 1 tenth right over there. And to that, we want to add 8 tenths. So 1, 2, 3, 4, 5, 6, 7, 8. And so how many total tenths do I now have? Well, let's just count them up. We have this 1 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are really saying the same thing. All of this together is going to be, all of this together is going to be 9 tenths. Now in either case, how do we write 9 tenths in decimal form? Well, we go to the tenths place, which is 1 space on the right side of the decimal. We say, hey, we have 9 tenths. This is the tenths space right over here. So that's just saying we have 9 tenths. We have 9 of these tenths right over here. So let's keep building. Let's do another example. So let's say that we clear all of this out. So let's say that we want to add, do these with different colors. So let's say we want to add, I have trouble, my pen isn't working. Let's see. Let's say we want to add, my pen is, oh here we go. Let's say we want to add 3 tenths, and to that we want to add 9 tenths. What is that going to be? Well, you could use the same idea. If you say this is 3 tenths and this is 9 tenths plus 9 tenths. Well, if I have 3 of something and if I add 9 of them, well, that's going to be 12. 3 plus 9 is 12. So we could say this is going to be equal to 12 tenths. Now, this one might be a little bit counterintuitive. 12 tenths. What does that mean? Well, one way to think about it, this is 10 tenths plus 2 tenths. And what are 10 tenths? Well, if I have 10 tenths, this right over here is 1 whole. So that is going to be 1. So we have 1 and 2 tenths. So how do we write 1 and 2 tenths? Well, we could write it as, in the ones place, we just write a 1. And then in the tenths place, we write our 2 tenths. So you could say it's equal to 1.2, or you could say it's equal to 1 and 2 tenths, which is the same thing as 12 tenths. Now, if we want to see that visually, let's get our diagram out again. So actually, I'm going to put 2 of these here. So 1, and then a second one. And we want to add, so let's start with the 3 tenths. Let me color these in really fast. So use that light blue color. So that is 1 tenth. This is 2 tenths. Just coloring them in really fast. And this is 3 tenths. And then to that, we're going to add 9 tenths. So to that, we're going to add 1, 2, 3. I'm not coloring them in fully. 4, you get the idea. 5, almost there. 6, I need to color faster. 7, 8, 9. So there you have it. I have added 9/10. You notice I've colored in yellow 9 of the tenths, and before I had 3 of the tenths colored in. And when you add them all together, what happens? Well, the 3/10 plus the 7/10 right over here, they made a whole. So this right over here is our 1. And then we also have another 2/10 left over. And so this is our 0.2 or 2/10. So it's going to be 1 plus 2/10, which is 1.2. So hopefully this gives you a good sense of how we think about adding decimals. And even though in the future we're going to figure out faster ways of doing it or more systematic ways of doing it, this is still the way that I still do it in my head. If someone walks up to me on the street and says, hey, add 0.3 to 0.9, that's how I think about it. So we are asked to drag the point to 12.5 on the number line. So let's see, this is 12, and then 12.5 is halfway between 12 and 13. Then they say, what is 12.5 rounded to the nearest 10? Well, what's cool about this is you can see on the number line that our 10s are in this blue hash. So we have 10 and then 20, and we're between 10 and 20. And which one are we closer to? Which is literally the nearest 10? Well, you can see we're closer to 10 than we are to 20. So you would say 10. And this helps us build an intuition for what rounding to the nearest 10 even means. Because you might know a rule like, hey, look, you go one place less than the tens place, which would be the ones place. And if it's less than 5 there, you round down to 10. If it's 5 or greater, you round up to 20. But you see why over here. We are just closer to 10. Let's do another example here. So here it says drag the point to 0.136. So this is 0.13. This is 0.14. So this is 13 hundredths, and this is 14 hundredths. And let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are, you could think of it as the 10 thousandths between these two hundredths. So we want to go 13 hundredths and then another 6 thousandths. So let's see, we go 1, 2, 3, 4, 5, 6, just like that. And then they say, what is this number, 136 thousandths, or 0.136, rounded to the nearest hundredth? Well, we have our hundredths in blue here, and which one are we closer to? Well, we're closer to 14 hundredths, 0.14. And that's consistent with what we've seen in other cases where you look at the thousandths place, and if it's 5 or greater, you round up. In this case, you would round up to 14 hundredths. Let's do a few more examples here. So let's say that, so they're asking us which point is at 44.197 on the number line. So let's see, that's going to be between 44 and 45, so it's right over here, 44.197, so that would be point C. And then they say, what is 44.197 rounded to the nearest whole number? Well, there's a couple of ways to think about it. You could just look at the tenths place and say, look, that's less than 5, so we round down to 44. Or a more intuitive way of thinking about it is like, look, point C is the number we care about. That is 44.197. Is it close? What's the closest whole number to it? Is it closer to 44 or is it closer to 45? Well, it's clearly closer to 44. So that's another reason why 44 makes a lot of sense. Let's do another example. Let's say that we want to, so they say, what is A rounded to the nearest thousandth? What is A rounded to the nearest hundredth? So A is right over here. Let's get our bearings. So 0.7, that's 7 hundredths. This is 8 hundredths right over here. And then between them, let's see, this looks like it's 0. This is, so you could view this as 70 thousandths, 71 thousandths, 72 thousandths, 73 thousandths, 74 thousandths, and so on. So this is between 78 thousandths and 79 thousandths. So if we round to the nearest thousandth, it looks closer, in fact, it's definitely closer to 78 thousandths than it is to 79 thousandths. So I would say this is 0.078 or 78 thousandths. It's closer, that's the nearest thousandth. What is A rounded to the nearest hundredth? Well, what are the hundredths that it's in between? It's in between 7 hundredths and 8 hundredths. And which one is it closer to? Well, it's closer to 8 hundredths. 0.08. So once again, the whole point of this video is to appreciate when people say round to the nearest whole number, to the nearest 10, to the nearest thousandth, to the nearest hundredth, you can think of it on a number line and just say, well, what is the closest hundredth to it? Or what hundredth is it closest to? Which thousandth is it closest to on the number line?
We're asked to move the orange dot to the number that equals 5 times 1/3. Alright, so one way to think about it, we just have to move 1/3 5 times. So let's do it once, so that's going to be 1/3. You do it twice, you get to 2/3. You do it 3 times, you get to 3/3. 4 times, you get to 4/3. 5 times, you get to 5/3. 5 times 1/3 is going to be 5/3. Or you could say 5 1/3, which is the same thing as 5/3. Hopefully that makes some sense. Let's do some more examples here. So let's say we need to figure out, so let's say it says move the orange dot to the number that equals 2 times 4/3. Alright, so 1 times 4/3 is just going to get us to 4/3. And then if we have another 4/3, we're going to add 4/3 to that. So we're going to move another 4/3 to the right. So 4/3 plus 4/3 would get us to 8/3. 8/3, I'm having trouble moving this. 8/3. So 1 times 4/3 is just 4/3. And then 2 times 4/3 is 8/3. And notice, that's the same thing as 2 times 4, which is 8 over 3. 8/3. Let's do one more of these. So move the orange dot to the number that equals 3 times 3 halves. So this is going to be 0 halves, that's just 0. So that's 0, you can view that as 0 times 3 halves. 1 times 3 halves, well that will just get us to 3 halves. 2 times 3 halves, we'll add another 3 halves, so that'll get us to 6 halves. And then 3 times 3 halves, we'll add another 3 halves. That gets us to 9 halves. And we're done.
We're asked to figure out what is 1/7 divided by 4, and they help us out with this diagram. We have a whole divided into 7 equal sections. Each of those is a 7. And we have one of those 7ths filled in. So this is 1/7 right over here. And then they divide it into 4 equal sections. In fact, they divide all of the 7ths into 4 equal sections. And so 1/7, which is this whole green bar, divided by 4, well, that would be this fraction of the whole that is in a question mark. So can you pause this video and figure out what fraction of the whole is this question mark? Well, when we divided the first 7th into 4 equal sections, we also divided all of the 7ths into 4 equal sections. And so now the entire whole is 28 equal sections because you have a 4 by 7 grid. You have 1, 2, 3, 4 rows, and you still have your 7 columns. And you could count them: 7, 14, 21, 28. And so 1/7 divided by 4 is going to be one of these 28 sections. So this right over here is 1 over 28. So this is 1/28. Let's do another example. We're told use the number line below to help visualize 1/5 being divided by 3. So as we go from 0 to 1 on the number line, you could divide into 5 equal sections where that's 1/5, 2/5, 3/5, 4/5, and of course 5/5 is equal to 1. But we want 1/5 divided by 3. So we took the section from 0 to 1/5 and we divided it into 3 equal sections. And so the first of those sections, this one right over here, that would be 1/5 divided by 3. So what is this going to be equal to? Pause this video again and see if you can figure that out. Well, the key realization is when we divided each of the fifths into 3 more equal sections, we can now think of each of these steps as a 15th, because now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 equal sections between 0 and 1. And where did that 15 come from? Well, we had 5 equal sections, and then we split each of those 5 into 3 more equal sections, so 5 times 3 is 15. So this right over here is 1/15, this is 2/15, this is 3/15, which is equivalent to 1/5, and we could keep going on and on and on. But the key realization here is, if I take that first 1/5, and if I divide into 3 equal sections, and I go only as far as that first of the 3 equal sections, that is going to be 1/15. 1/15. And we are done.
So in this video, we're going to think about dividing numbers where the quotient, the result of our division, might result in a decimal. So let's say we wanted to compute what 5 divided by 2 is. In the past, you might have said, hey, 2 times 2 is 4, and then you have 1 left over, and so you might have said something like this. This is 2 with a remainder of 1. But now we don't want to just say, hey, how many times can it go in and what's left over? We want to know exactly how many times can 2 go into 5. So we want a decimal answer right over here. So pause this video and see if you can figure that out. All right, now let's work through this together. And there's many ways that we can approach this. One way is to realize that 5 divided by 2, we can re-express as 5 divided by 2, or as 5 halves. And 5 halves is the same thing as 4 plus 1 over 2, which is the same thing as 4 halves plus 1 half, which is the same thing as 4 halves is 2. Let me do that in a different color. This part over here is 2, and then you have this 1 half. So it's the same thing as 2 and a half. And if we were to express that as a decimal, that's going to be equal to 2 and how many tenths is equal to a half? Well, 5 tenths is equal to a half. So 5 divided by 2, you could say, is 2.5. Now, another way that you could approach this is you say 5 divided by 2 is the same thing as 50 tenths divided by 2. So let me use a different color here. So instead of a 5, I could say 5 is the same thing as 50 tenths divided by 2. And so if I have 50 of something, and if I were to divide it by 2, well, that's going to result in 25 of the something. So this is going to be equal to 25 tenths. And how would we express 25 tenths as a decimal? Well, this is going to be equal to, I could put some place values here. So we definitely have 5 tenths. I'll put that in the tenths place. And then 20 tenths is the same thing as 2 ones. And that's exactly what we had up here. Either way, you get 2.5, 2 ones and 5 tenths. Let's see if we can figure out what 2 divided by 0.1 or 1/10 is. Pause this video and see if you can figure that out. All right, now let's work through it together. And there's a couple of ways that we can approach it. One way is to think about everything in terms of tenths. So 2 wholes is how many tenths? Well, a whole is equal to 10 tenths, so 2 wholes is equal to 20 tenths. So I could rewrite the 2 as 20 tenths. And so that's going to be 20 tenths divided by, and instead of writing it this way, I can, instead of just writing it as 0.1, we know this is the same thing as 1/10. So divided by 1/10. And so if I have 20 of something, and if I divide it into groups of 1 of that something, how many groups am I going to have? Well, I'm going to have 20 equal groups of 1. So 20 tenths divided by 1/10 is equal to 20. Another way that you could approach that is you could rewrite the 0.1, the 1/10, as a fraction. We could rewrite this as 2 divided by, instead of writing 1/10 like this, I could write it as a fraction, divided by 1/10. Well, we know that dividing by a tenth is the same thing as multiplying by 10. So this is going to be equal to 2 times 10. And that gets us to the same place that we had before. What is 2 times 10? Well, that is going to be equal to 20. And that's good that we got to the same answer, otherwise these would not be equivalent methods. Let's do another example. So let's say we wanted to figure out what 6 divided by 1/10 is. Pause this video and see if you can figure that out. All right. Well, you could do the same idea. 6 wholes is equal to how many tenths? It's equal to 60 tenths. So I'll rewrite this as 60 tenths divided by 1/10 is equal to how many, is equal to what? Well, if I have 60 of something, and if I divide it into groups of 1 of that something, I'm going to have 60 equal groups of 1. So this is going to be equal to 60. So you might see a pattern. When we divide by a tenth, we end up multiplying by 10. When we divide by a tenth, we are multiplying by 10. And you could do the same thing as we saw up here. You could say 6 divided by 1/10 is the same thing as 6 divided by 1/10 written as a fraction, which is going to be equal to 6 times, you could say 6 times 10 or 6 times 10 over 1, either way, 6 times 10 over 1, or which is the same thing as 10, which is once again going to be equal to 60. So I think you see the general pattern. Divide by a tenth, same thing as multiplying by 10. Now what about if we dealt with hundredths? So let's say we want to figure out what 7 divided by a hundredth is. What would this be? Pause this video and try to figure it out. Alright, well we can do the same drill. So 7 wholes, 1 whole is equal to 100 hundredths, so 7 wholes is equal to 700 hundredths. So this is equal to, I'll write it like this, 700 hundredths divided by 1 hundredth. 1 hundredth. If I have 700 of something, and if I'm dividing it into equal groups of 1 of that something, I'm going to have 700 equal groups. So this is going to be equal to 700. So you divide by a hundredth is the same thing as multiplying by 100. Now you could also rewrite this as a fraction if you like, so that some of the principles we saw up here still apply. So we could rewrite this as 7 divided by 1 hundredth
And so this is going to be the same thing as 7 times 100 over 1, or 7 times 100. 7 times 100, which once again will get you to 700. So I think you see a pattern. Divide by 10th, same thing as multiplying by 10. Divide by 100th, same thing as multiplying by 100.
Let's say I have the number 905. 905.074. So how could I expand this out? What does this actually represent? So let's just think about each of the place values here. The 9 right over here, this is in the hundreds place. This literally represents 9 hundreds. So we could rewrite that 9 as 9 hundreds, or let me write it two ways. We could write it as 900, which is the same thing as 9 times 100. Now this is 0, that's just going to represent 0 tens, but 0 tens is still just 0, so we don't have to really worry about that. It's not adding any value to our expression or to our number. Now we have this 5. This 5 is in the ones place. It literally represents 5 ones, or you could just say it represents 5. Now if we wanted to write it as 5 ones, we could say, well, that's going to be 5 times 1. So far we've represented 905. 900 plus 5, or 9 times 100 plus 5 times 1. And you might say, hey, how do I know whether I should multiply or add first? Should I do this addition before I do this multiplication? And I'll always remind you, order of operations, in this scenario, you would do your multiplication before you do your addition. So you would multiply your 5 times 1 and your 9 times 100 before adding these two things together. But let's move on. You have another 0. This 0 is in the tenths place. This is telling us the number of tenths we're going to have. This is 0 tenths, so it's really not adding much. Or it's not adding anything. Now we go to the hundredths place. The hundredths place. So this literally represents 7 hundredths. So we could write this as 7 hundredths, or 7 times 100th. So plus 7 times 100th. And then finally we go to the thousandths place. So we go to the thousandths place, and we have 4 thousandths. So that literally represents 4 over 1,000, or 4 times 1,000th. 4 times 1,000th. Notice, this is coming from the hundreds place. This is coming from the hundreds place. You have 0 tens, but I'll write the tens place there just so you see it. So it's 0 tens, so I didn't even bother to write that down. Then you have your ones place. You have 5 ones. Then you have 0 tenths, so I didn't write that down. Then you have 7 hundredths. 7 hundredths. And then you have 4 thousandths. 4 thousandths. And we are done. We've written this out, really just understanding what this number represents. What we're going to do in this video is explore place value involving decimals. And in particular, we're going to think about how you can regroup value from one place to another, which is going to be very useful later in your life when you start doing some more arithmetic with decimals. So let's first think about what this number is right over here. So each square represents a 1, or represents a whole. So what number is this? Well, you could see that we have 3 whole ones, so we could write 3. And then we have right over here, a whole is divided into 10 equal bars, these vertical bars. And so each of these are a tenth, and 4 of them are shaded in. So it's 3 ones, 4 tenths, and in this part right over here, we've divided a whole into 100 equal sections. It's a 10 by 10 grid, and we can see that 1, 2, 3, 4, 5, 6, 7 of them are shaded in. So this represents 7 hundredths. So this is 3.47, or 3 and 4 tenths and 7 hundredths, or 3 and 47 hundredths. Now what we're going to do is explore how are other ways you can put the value into the different places. So let me set up a little table here. I don't think I'm going to need all that space, but we have in this first example, so we have our ones place, we have our tenths place, and we have our hundredths place. I had to curve up a little bit. And so what we just did is we said, hey, this was pretty straightforward. This was 3 ones, 4 tenths, and 7 hundredths. 7 hundredths. But are there other ways that we could look at it? For example, is there a way of reimagining this? So instead of 3 ones, we have 2 ones, and we still have 7 hundredths. So how many tenths would we have in order for it to be the same value? Pause this video and think about that. All right, we'll do it together, and to help us, I will put what we had here just now. Now what's different, instead of having 3 ones, we now have 2 ones. So we could say that these are our 2 ones right over here. Our 2 ones. We have our 7 hundredths right over here. So essentially we would have to express all of this in terms of tenths. So how would we express it all in terms of tenths? Well, this, what used to be a 1, this is equivalent to 10 tenths. Let me make that very clear. I could, actually, let me see if I could shade this in with that green color. So there you go. I'm going to shade it with the green color, and then let me draw a bunch of lines here to make it very clear. So I'm just going to hand draw it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I didn't draw it as straight as I need to. They really should be 10 equal sections, but it was hand-drawn, so I think you understand. And so look, notice, I took the exact same value, but I have regrouped. I have regrouped this 1 right over here into tenths. And so how many tenths are here? Well, now I have 10 plus 4 tenths. So now I have, shaded in, 14 tenths. That was interesting. Let's do another example. So now let's imagine another scenario. Let's imagine a scenario where we have 3 ones again, but this time, instead of having 7 hundredths, we have 27 hundredths. So in that circumstance, how many tenths would we have? Pause this video and see if you can work it through. All right, well, let's get that same number again. And now let's think about how we might have to regroup between the places. So we have our 3 ones. So that was just like the first case right over there. So we have our 3 ones. But now we have 27 hundredths. So in addition to these 7 hundredths, we have to find another 20 hundredths someplace. Well, the most natural place to go would be right over here. And 20 hundredths is the same thing as 2 tenths. So what we want to do is we would convert these 2 tenths into hundredths. And so let me actually just shade it in a little bit. So I'm going to convert this right over here to hundredths. And so there, did I do that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so there you have it. This plus this gives us our 27 hundredths. And so how many tenths do we have left? We have 2 tenths. 2 tenths. So in this situation, we regrouped 2 from the tenths place, and we expressed them as hundredths. So 2 tenths became 20 hundredths, added to the 7 hundredths that you already have, and we now have 27 hundredths. Hopefully that makes sense.
When we were first exposed to multiplication and division, we saw that they had an inverse relationship, or another way of thinking about it is that they can undo each other. So for example, if I had 2 times 4, one interpretation of this is I could have 4 groups of 2, so that is 1 group of 2, 2 groups of 2, 3 groups of 2, and 4 groups of 2, and we learned many videos ago that this of course is going to be equal to 8. But we could express a very similar idea with division. We could start with 8 things, so start with 1, 2, 3, 4, 5, 6, 7, 8 things. So now we're going to start with the 8, and we could say, well, let's try to divide that into 4 groups, 4 equal groups. Well, that's 1 equal group, 2 equal groups, 3 equal groups, and 4 equal groups. And we see when we start with 8, divide into 4 equal groups, each group is going to have 2 objects in it. So you probably see the relationship. 2 times 4 is 8, 8 divided by 4 is 2, and actually if we did 8 divided by 2, we would get 4. And this is generally true. If I have something times something else is equal to whatever the product is, if you take the product and divide by one of those 2 numbers, you'll get the other one. And that idea applies to fractions, and it actually makes a lot of sense with fractions. So for example, let's say that we started off with 1/3, and we wanted to multiply that times 3. Multiply by 3. Well, there's a couple of ways we could visualize it. Actually, let me just draw a diagram here. So let's say that this block represents a whole, and let me shade in 1/3 of it. So that's 1/3. but we're going to multiply by 3. So we're going to have 3 of these 1/3. Or another way of thinking about it is going to be 1/3 times, or 1/3 plus another 1/3 plus another 1/3. That's our first third, our second third, and our third third, and we get the whole. This is 3/3 or 1. So this is going to be equal to 1. So you use the exact same idea. If 1/3 times 3 is equal to 1, then that means that 1 divided by 3, must be equal to 1/3. Must be equal to 1/3. And this comes straight out of how we first even thought about fractions. The first way that we ever thought about fractions was, well, let's start with a whole, and that whole would be our 1. And let's divide it into 3 equal sections, the same way that we divided this 8 into 4 equal groups. So if you divide this into 3 equal sections, the size of each of those sections is going to be exactly 1/3. Now this leads to an interesting question that might be popping in your brain. Notice we have 1 as a numerator, 3 as a denominator, and we just said that this is equal to the numerator divided by the denominator. 1/3 is the same thing as 1 divided by 3. Is this always true for a fraction? Well, let's just do the same thought experiment, but let's do it with a different fraction. Let's take 3/4 and multiply it by 4. So multiply it by 4. So once again, let's see if I could draw a fourth here. Let me do this in a new color. So I'll take, let's say that this block right over here is a whole. I'm going to divide it into 4 equal sections. So now I've divided it into fourths, and let me copy and paste it so I can use it multiple times. So copy. All right. Now 3/4. That's going to be, well, we can assume I didn't draw it perfect. Actually, I could draw it a little bit better than that just to make the 4 equal sections actually look equal. So that looks like a little bit better of a job. I'm trying to make them 4 equal sections. And let me copy that one. So let me use it for later. Now, 3/4. This is 4 equal sections, and 3/4 represents 3 of them. 1, 2, 3. But now we're going to multiply it by 4. So we're going to have 3/4 4 times. So we're going to need some more holes here. So let's throw in another hole. So this is 1/3. Now let me do the next 3/4 in another color. So this is another, that's a fourth, that's a second fourth, that's a third fourth. That's another 3/4. And now let's do, so we've done 2 3/4 just now. Let me make it clear. This is the first 3/4, and then this plus this is the second 3/4. Now let's do a third 3/4, and we're gonna have to use another hole right over here, and I will do that in this color. So my third 3/4. So here's a fourth, here's my second fourth, here's a third fourth. So in green I have another 3/4, and now we need 4 3/4. So let's do that in a color I have not used yet, maybe white. So that's a fourth, that's 2/4, and that is 3/4. So notice now I have 1 3/4, 2 3/4, 3 3/4, and 4 3/4. And what did I do when I got those 4 3/4? Well, it's pretty clear. This is turned into 3 wholes. So this is equal to 3 wholes. Well, if 3/4 times 4 is equal to 3, that means that 3 divided by 4 is equal to 3/4. So the same idea again. 3/4 is the same thing as 3 divided by 4. And in general, this is true. The fraction symbol here can be interpreted as division. And looking at this diagram right here, it made complete sense. If you started with 3 wholes and you want to divide it into 4 equal groups, 1 group, 2 groups, 3 groups, 4 groups, each group is going to have 3/4 in it. So we've got a rectangle here. It's 5/9 of a meter tall and 7/8 of a meter wide. What is its area? And I encourage you to pause the video to think about that. Well, one way to think about it, you can say, okay, our area is just going to be the width times the height. We're just going to multiply these two dimensions. And so the width is 7/8 of a meter. So it's going to be 7/8 of a meter times the height, which is 5/9 of a meter, times 5/9 of a meter. And what's that going to get us? Well, that's just going to be equal to the meters times the meters give us square meters. So meters squared, we could write it like that. And then we're going to have 7 times, this is a new color. We're going to have 7 times 5 in the numerator to get us 35. And then in the denominator, we are going to have 8 times 9 to give us 72. And we'd be done. This is the area of this rectangle here. It's 35/72 of a square meter. What I want to do now is think a little bit deeper about why that actually makes sense, or just really another way of thinking about it. And to do that, what I'm going to do is I'm going to split this region into equal rectangles. So let's split it into equal rectangles.
And we see that we have 7, if we go in the horizontal direction, we have 1, 2, 3, 4, 5, 6, 7. Or you can say in each row we have 7 of these rectangles. In each column you have 1, 2, 3, 4, 5 of these rectangles. So you can see we have 5 times 1, 2, 3, 4, 5, 6, 7. So we have 5 times 7 of these rectangles. So we have 35. We have 35 rectangles. I'll just write this, 35 rectangles. And what's the area of each of those rectangles? Well, if this is 7/8 meters wide, and this is divided into 7 equal sections in the horizontal direction, that means that each of these is exactly 1/8 of a meter wide. And by that same logic, each of these, if this whole thing is 5/9, and the height of each of these is 1/5, because we have five rectangles per column, then the height of each of these is going to be 1/9 of a meter. So what's the area of just this character right over here? Well, it's going to be 1/9 of a meter times 1/8 of a meter. So this area right over there is just going to be 1/9 of a meter times 1/8 of a meter, which is equal to 1 times 1 is 1, 9 times 8 is 72, and meters times meters is square meters. So the area of each of these 35 is 1/72 of a square meter. So I can say 35, so the area of all of them combined is going to be 35 times the area of each of them. 35 times 1/72 of a square meter. And what's that going to be? Well, that's going to be exactly what we got up here. 35 times 1/72 of a square meter is going to be 35 70 seconds of a square meter. And this 35 is the same one that we had in yellow. That's this one right over there. So once again, you can just multiply 5/9 times 7/8 to get what we have got here. But hopefully when we thought about the area of each of these rectangles, it might make a little bit more intuitive sense where this number came from.
Multiply 1 3/4 times 7 1/5. Simplify your answer and write it as a mixed fraction. So the first thing we want to do is rewrite each of these mixed numbers as improper fractions. It's very difficult, or at least it's not easy for me to directly multiply mixed numbers. One can do it, but it's much easier if you just make them improper fractions. So let's convert each of them. So 1 3/4. 1 3/4 is equal to, it's still going to be over 4, so you're still going to have the same denominator, but your numerator as an improper fraction is going to be 4 times 1 plus 3. 4 times 1 plus 3. And the reason why this makes sense is 1 is 4/4, or 1 is 4 times 1/4, right? 1 is the same thing as 4/4, and then you have 3 more fourths, so 4/4 plus 3/4 will give you 7/4. Will give you 7/4, so that's the same thing as 1 3/4. Now, let's do 7 1/5. 7 1/5. 7 1/5. Same exact process. We're going to still be talking in terms of fifths. That's going to be the denominator. And we take 5 times 7, because think about it, 7 is the same thing as 35 fifths. So you take 5 times 7, so it's 5 times 7, plus this numerator right here. So 7 is 35 fifths, then you have 1 more fifth, so you're going to have 35 plus 1, which is equal to 36 fifths. So this product is the exact same thing as taking the product of 7 over 4 times 36 over 5. Times 36 over 5. And we could multiply it out right now, take the 7 times 36 is our new numerator, 4 times 5 is our new denominator, but that'll give us large numbers. I can't multiply 7 and 36 in my head, or I can't do it too easily. So let's see if we can simplify this first. So both our numerator and our denominators have numbers that are divisible by 4. So let's divide both the numerator and the denominator by 4. So the numerator, we can divide the 36 by 4. We can divide the 36 by 4 and get 9. And if you divide something in the numerator by 4, you have to divide something in the denominator by 4, and the 4 is the obvious guy. So 4 divided by 4 is 1. So now this becomes 7 times 9. And what's 7 times 9? It's 63 over 1 times 5 over 5. So now we have our answer as an improper fraction, but they want it as a mixed number, or as a mixed fraction. So what are 63 fifths? So to figure that out, let me pick a nice color here. We take 5 into 63. 5 goes into 6 one time. 1 times 5 is 5. You subtract. 6 minus 5 is 1. Bring down the 3. 5 goes into 13 2 times. And you could have immediately said 5 goes into 63 12 times, but this way it's at least to me it's a little bit more obvious. And then 2 times 5 is 12. And then we have, 2 times 5 is 10. 2 times 5 is 10. It tells you not to switch gears in the middle of a math problem. 2 times 5 is 10, and then you subtract, and you have a remainder of 3. So 63 fifths is the same thing as 12 wholes and 3 left over, or 3 fifths left over. And if you wanted to go back from this to that, just think, 12 is the same thing as 60 fifths, or 60 over 5. 60 over 5 plus 3 over 5 is 63 over 5. So these two things are the same thing. These two things are equivalent. This is as an improper fraction. This is as a mixed number, or a mixed fraction. But this is our answer. Right there, 12 and 3/5.
So we have here 2 2/3 plus 8 3/4. And I encourage you to pause the video and see if you can compute what this is. So now let's work through this together. And there's a bunch of ways that you can tackle this. I'll do it in a couple of different ways. So one way that you might see is to just rewrite this expression. To just rewrite 2 2/3 plus 8 3/4 plus 8 3/4. And you might be saying, why would I rewrite it this way? Well, when you rewrite it this way, it's very clear that these are the fraction parts of the mixed numbers, and these are the whole number parts of the mixed numbers, and maybe we can add them separately. But before we even start adding the fraction parts of the mixed numbers, we notice that we have different denominators here. We have a 3 and we have a 4, so it'd be nice to find a common denominator, and we've seen multiple times in the past when you're adding fractions with unlike denominators, a good common denominator would be their least common multiple, the least common multiple of 3 and 4. Well, what's that going to be? Well, let's look at the multiples of 4. 4 is not perfectly divisible by 3. 8 is not perfectly divisible by 3. 12 is. In fact, 12 is 4 times 3. So I can rewrite both of these fraction parts with 12 as their denominator. So this is going to be equal to, let me just write it this way. So I can rewrite it as 2 and something over 12. Now what would be that something over 12? To go from 3 to 12 in the denominator, we multiply by 4. So we have to multiply the numerator by 4 as well. So 2 times 4 is 8. 2/3 is the same thing as 8/12. So 2 2/3 is the same thing as 2 and 8/12. And then we can do the same thing down here. 8 3/4 is going to be the same thing as 8 and something over 12. Well, to go from 4 to 12 in the denominator, you multiply by 3. So we have to multiply the numerator by 3 as well. 3 times 3 is 9. And now we can add. And what do we get? Well, we have 8/12 plus 9/12. That's going to be 17/12. Well, you might recognize 17/12. This is greater than or equal to 1. So we could actually, this is an improper fraction right over here. So we can actually rewrite this. We can rewrite this as a mixed number. Let me make it clear. 17/12. So put it right over here. 17 over 12 is the same thing as 1 and 5/12. How did I figure that out? 12 goes into 17 one time, and then I still have 5 left over. 17/12 is the same thing as 1 and 5/12. So what I could do is I could write the 5/12 part in the fraction part of our, or I guess say the fraction place on our numbers, and then I can regroup the 1, put it in the whole number column. And now I can just add the 1 plus 2 is 3 plus 8 is 11. So we get 11 and 5/12. 11 and 5/12. Now there's other ways that we could have tackled this. What we could have done is gone from this place, right over here, the 2 and 8/12 and the 8 and 9/12, and we could have converted these into improper fractions, then added those improper fractions. So we could have said that this is the same thing. Let me rewrite it as, let's see, 2 is the same thing as 24/12 plus 8 is going to be 32/12. So I could rewrite this top mixed number as 32 over 12, clearly an improper fraction. And I could rewrite this bottom mixed number as, let's see, 8 is how many 12ths? That's going to be 96/12 plus another 9/12 is 105/12. 105/12. If what I just did looks a little bit confusing, you should review the Khan Academy videos on converting mixed numbers to improper fractions or vice versa. But now I could think about adding these two. And what would I get? I would get 32/12 plus 105/12, which would be, what, 137/12. And then if we wanted to rewrite this as a mixed number, we could say, okay, let's see, 12 will go into 137 11 times. So it goes 11 times. 11 times 12 is 132, so you'd have 5 left over. So it's 11 and 5/12. So you could have done it either way. I think the way we did it the first time would have been a little bit easier because you didn't have to deal with these really big numbers like 137 and 105 and 32, and you just dealt with more straightforward numbers. You say, hey, look, 8/12 plus 9/12 is 17/12, which is the same thing as 1 and 5/12. And then you add 1 and 5/12 plus 2 plus 8 is going to give you 11 and 5/12. Let's think about how or what 1/2 times 5 represents. So one way to think about it is that this could be 5 1/2s added together. So you could view this as 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2, which is the same thing as 1 plus 1 plus 1 plus 1 plus 1 over 2, which is equal to 5 halves, which is equal to 5 halves. The other way to think about this is that you start with 5 things. So let's say that's one thing. Let me copy and paste that so they all look the same. So, and then let me paste it. So that's 2 things, that's 3 things, that's 4 things, and then that's 5 things. So the other way to think about it is you start with 5 things and you take half of them. So what would be half of this? Well, let's see. You have 5 things, so you would get 5 divided by 2 would be 2.5. So you would get this far. Let me make it like this. So you would get this one, you would get this one, and you would get this one. Now, is this the same thing as 5 halves? Well, what happens if we divide each of these wholes into halves? So let's do that. So if we just divide each of these into 2. So we have, instead of having 5 holes, we now have 10 halves. We now have 10 halves. How many of those halves have we filled in? Well, we have filled in 1, 2, 3, 4, 5. So this is also equal to 5 halves. Now, if you're looking for how we could, right now, so far we just did it thinking about what multiplication actually means. But if you said, well, how did I compute this? Well, the way you could think about it, and multiplying fractions is actually straightforward from that point of view, is as long as you can express both of them as fractions, and 5 we already know is the same thing as 5 ones. So this we can just multiply times 5 over 1. 5 over 1. So now that I've expressed both of them as fractions, I can just multiply the numerator. So 1 times 5 over 2 times 1. Over 2 times 1. And what's that going to be equal to? Well, 1 times 5 is 5. 2 times 1 is 2. 2 times 1 is 2. So once again, we get 5 halves. We've already seen that the fraction 2/5, or fraction like the fraction 2/5, can be literally represented as 2 times 1/5. 2 times 1/5, which is the same thing, which is equal to literally having 2 1/5. So 1/5 plus 1/5. And if we wanted to visualize it, let me make a hole here and divide it into 5 equal sections. And so this represents 2 of those fifths. This is the first of the fifths, and then this is the second of the fifths. Literally 2 fifths, 2 fifths, 2 fifths. Now let's think about something a little bit more interesting. What would 3 times 2 fifths represent? 3 times 2 fifths. And I encourage you to pause this video and based on what we just did here, think about what you think this would be equivalent to. Well, we just saw that 2 fifths would be the same thing as, so let me just rewrite this as instead of 3 times 2 fifths written like this, let me write 2 fifths like that. So this is the same thing as 3 times 2 times 1/5. 3 times 2 times 1/5 times 1/5. And multiplication, we can multiply the 2 times the 1/5 first and then multiply by the 3, or we can multiply the 3 times the 2 first and then multiply by the 1/5. So you could view this literally as being equal to 3 times 2 is, of course, 6. So this is the same thing as 6 times 1/5. 6 times 1/5. And if we were to try to visualize that again, so that's a hole, that's another hole. Each of those holes have been divided into 5 equal sections, and so we're going to color in 6 of them. So that's the first fifth, second fifth, third fifth, fourth fifth, fifth fifth, and that gets us to a hole, and then we have 6 fifths, just like that. So literally 3 times 2 fifths can be viewed as 6 fifths. And of course, 6 times 1/5 or 6 fifths can be written as, so this is equal to literally 6, let me do the same color, 6 fifths, 6 over 5. Now you might have said, well, what if we, instead of viewing 2 fifths as this, as we just did in this example, we view 2 fifths as 1/5 plus 1/5. What would happen then? Well, let's try it out. So 3 times 2 fifths, I'll rewrite it. 3 times 2 fifths, 2 over 5, 2 fifths, is the same thing as 3 times 1/5 plus 1/5. 2 fifths is the same thing as 1/5 plus 1/5. So 3 times 1/5 plus 1/5, which would be equal to, well, I just have to have literally 3 of these added together. So it's going to be 1/5 plus 1/5 plus 1/5 plus 1/5 plus, I think you get the idea here, plus 1/5 plus 1/5. Well, what's this going to be? Well, we literally have 6 fifths here. We can ignore the parentheses and just add all of these together. We once again have 1, 2, 3, 4, 5, 6 fifths. So once again, this is equal to 6 fifths. So hopefully this shows that when you multiply that 2 fifths we saw already represents 2 1/5ths. We already saw that, or 2 times 1/5. And 3 times 2 fifths is literally the same thing as 3 times 2 times 1/5. In this case, that would be 6 fifths. Let's think a little bit about what it means to multiply fractions. Say I want to multiply 1/2 times 1/4. Well, one way to think about this is we could view this as 1/2 of a fourth. And what do I mean there? Well, let me take a hole. Let me take a hole here, and let me divide it into fourths. So let me divide it into fourths. So I'll divide it into 4 equal sections. And so 1/4 would be one of these 4 equal sections. But we want to take 1/2 of that. So how do we take half of that? Well, we could divide this into 2 equal sections and just take one of them. So divide it into 2 equal sections and then take one of them. So we're taking this pink area is 1/2, and we're going to take, or sorry, this pink area, this whole pink area is 1/4, and now we're going to take half of it. We're now going to take half of it. So that's this yellow square right over here. But what fraction of the whole does this yellow represent? Well, it now represents 1 out of 1, 2, 3, 4, 5, 6, 7, 8 equal sections. So this right over here represents 1/8 of the whole. And so we see conceptually that 1/2 times 1/4, it completely makes sense that 1/2 of 1/4 should be 1/8. And it hopefully makes sense that you get this 8 by multiplying the 2 times the 4. You started with 4 equal sections, but then you divided each of those 4 equal sections into 2 equal sections, so then you have 8 total equal sections that you split your whole into. Let's do another example, but now let's multiply 2 fractions that don't have 1s in the numerator. So let's multiply 2/3 times 4/5. And I encourage you now to pause the video and do something very similar to what I just did. Try to represent 4/5 of a whole, and then try to represent 2/3 of that 4/5 and see what fraction of the whole you actually have. So pause now. So let's think about this. Let's represent 4/5. So if I have a whole like this, let me try to divide it into 5 equal sections. 5 equal sections. So let's say that is 1 equal section, that is 2 equal sections, that is 3, 4, and 5. I can do a better job of this. This is always the hard part. I'm trying my best to make them look at least like equal sections. 2, 3, 4, and 5. I think you get the point here. I'm trying to make them equal sections. And we want 4/5. So we want 4 of these 5 equal sections. So this would be 1 of the 5 equal sections, 2 of them, 3 of them, and then 4 of them. So that right over there is 4/5. Now we can view this as 2/3 of the 4/5. So how can we think about that? Well, we can take this section and divide it into thirds. So let's do that. Divide it into thirds. So we're going to divide it into 3 equal sections. So that's 1/3 and then 2/3. So we took each of the 5 equal sections and we divided them into 3 equal sections. Now what's going to be 2/3 of the 4/5? Well, that's going to be this part right over here. So let me make this clear. This is 1/3 of the 4/5. And then this would be 2/3 of the 4/5. So this right over here would be 2/3 of the 4/5, or 2/3 times 4/5. But what fraction of the whole does that represent? Well, how many total equal sections do we now have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 equal sections. Let me do this in a new color. We have 15 equal sections, and that makes sense. We started with 5 equal sections, but then we divided each of those into 3 equal sections. So now we have 5 times 3 total equal sections. And then how many of those are now colored in? Well, we see it's 2 times 4. 1, 2, 3, 4, 5, 6, 7, 8. Or how many of them are in the 2/3 of the 4/5, I should say. And there's 8 of them. 8 of the 15 equal sections. And so there you have it. It should hopefully now make visual sense, or it makes conceptual sense, that 2/3 times 4/5, you can obviously compute it by just multiplying the numerators. 2 times 4 is 8, and then multiplying the denominators. 3 times 5 is 15. But hopefully this now makes conceptual sense as 2/3 of 4/5.
What we're going to do in this video is give ourselves practice representing fractions that you're going to see a lot in life in different ways. So the first fraction we're going to explore is 1/5. Then we're going to explore 1/4. Then we are going to explore 1/2. So let's start with 1/5. So I encourage you to pause the video and think about how would you represent 1/5 as a decimal. Well, there's a bunch of ways that you could think about it. You could divide 5 into 1. You could say that this is equal to 1 divided by 5. And if you did that, you actually would get the right answer. But there's a simpler way of thinking about this, even in your head. You could say, well, let me see if I can represent this as a certain number of tenths. Because if you know how many tenths, we know how to represent that as a decimal. Well, to go from fifths to tenths, you have to multiply the denominator by 2. So let's multiply the numerator by 2 as well. So 1/5, 1 times 2 is the same thing as 2 tenths. And we know how to represent that in decimal notation. That's going to be 0.2. This is the tenths place. So we have exactly 2 tenths. Now let's do 1/4. Same idea. How can I represent this as a decimal? Well, at first you might say, well, can I represent this as a certain number of tenths? And you could do it this way, but 10 isn't a multiple of 4. So let's see if we can do it in terms of hundreds, because 100 is a multiple of 4. Well, to go from 4 to 100, you have to multiply by 25. So let's multiply the numerator by 25 to get an equivalent fraction. So 1 times 25 is 25. So 1/4 is equal to 25 hundredths, and we can represent that in decimal notation as 25 hundredths, which we could also consider 2/10 and 5 hundredths. Now let's do 1/2. Same exact idea. Well, 10 is a multiple of 2, so we can think about this in terms of tenths. So to go from 2 to 10, we multiply by 5. So let's multiply the numerator by 5 as well. So 1/2 is equal to 5/10, which if you want to represent it as a decimal is 0.5, 5/10. Now why is this useful? Well, one, you're going to see these fractions show up a lot in life, and you're going to go both ways. If you see 2/10 or 20 hundredths, to be able to immediately recognize, hey, that's 1/5, or 25 hundredths, hey, that's 1/4, or 1/4, that's 25 hundredths. 1/2 is 0.5, or 0.5 is 1/2. And it's not just useful for these 3 fractions, it's useful for things that are multiple of these 3 fractions. For example, if someone said, quick, what is 3/5 represented as a decimal? Well, in your brain, you can say, well, 3/5, that's just going to be 3 times 1/5. And I know that 1/5 is 2/10. So that's going to be 3 times 2/10, which is, well, 3 times 2 is 6, so 3 times 2/10 is 6/10. So really quick, you were able to say, hey, that's 3/5 is 6/10. And you could have gone the other way around. You could have said 6/10 is equal to 2 times, is equal to 3 times 2/10. And 2/10, you know, is 1/5. So this is going to be equal to 3 times 1/5. And once again, these are just things that you'll get comfortable with the more that you get practice. Let's do another one. Let's say you wanted to represent, let me do it another way, 0.75 as a fraction. Pause the video, try to do it yourself. Well, you might immediately recognize that 75 is 3 times 25, so 75 hundredths is equal to 3 times 25 hundredths. And 25 hundredths, we already know, is 1/4. So this is equal to 3 times 1/4, which is equal to 3/4. And over time, you won't have to do all of this in your head. You'll just recognize 75 hundredths, that's 3/4, because 25 hundredths is 1/4. And now let's say we have 2.5, and we want to represent that as a fraction. Well, there's a bunch of ways that you could do this. You could say, well, this is 5 times 0.5, and that's going to be 5 times 1/2. Well, that's going to be 5 halves. It's an improper fraction, but it's a fraction. And so once again, the whole point here, and you might already be familiar with different ways of converting between fractions and decimals, but if you recognize 1/5, 1/4, 1/2, it's going to be a lot easier. Notice if you did it the other way around, it would be a little bit more work. If I said, let me convert 3/5 to a decimal, well, then you would have to divide 5 into 3. 5 into 3. And you'd say, okay, 5 goes into 3 0 times. So let's put a decimal here. Now let's go to 30. 5 goes into 30 6 times. 6 times 5 is 30. You subtract, and then you get no remainder. So this wasn't a ton of work, but this one, the reason why I like this one, not only is it faster, but it gives you a better intuition for what actually is going on. If 5 is divided into pieces that are each 1/2 of a whole, how many pieces are there? And this would be the equivalent of saying, what is 5 divided by 1/2? And they help us out with this visual. So pause this video and see if you can figure out what that is. How many pieces would you get if you divide 5 into pieces that are each 1/2 of a whole? All right, now let's work through this together. So here on this number line, we go from 0 to 5. And then notice, they've divided into pieces that are each 1/2 of a whole. This is one piece right over here. So how many of those halves, so this right over here is 1/2. How many of those halves does it take to make 5? Well, 2 halves make a whole, and we have 5 wholes. So it's going to be 5 times 2 or 10. And we see that right over here. 1/2, 2, 3, 4, 5, 6, 7, 8, 9, 10 halves make 5 wholes. So this is going to be equal to 10. So 5 divided into pieces of 1/2, or 5 wholes divided into pieces of 1/2 would be equal to 10 pieces. Let's do another example. So we have a similar question here. Here we're asked, if 3 wholes are divided into pieces that are each 1/6 of a whole, how many pieces are there? Once again, pause this video and think about it. Well, they really help us out with this visual because we have 3 holes. This is 1 hole, 2 hole, and then 3 holes. And then we have divided them into pieces that are each 1/6 of a whole. This is a 1/6 right over here. This is a 1/6 right over here. So each of these are 1/6. And so if we look at this, we have 6 sixths in a whole. And so in 3 holes, we're going to have 6, 12, 18 pieces. And you could literally just count these up, but it makes sense. If you take 3 holes and you divide it into sixths, so this is a 1/6 right over here, each a 1/6. Each of these holes are going to be 6 sixths. So 3 holes are going to be 3 times 6 sixths, or 18 sixths. There you go.
So we want to figure out what 1/4 plus 3/5 minus 3/10 is. And I encourage you to pause the video and see if you could figure this out on your own. Alright, I'm assuming you've had an attempt. Let's work through this together now. So the first thing that might jump out at you is, look, I have these fractions that I'm adding and subtracting, but they all have different denominators. So in order to add and subtract them in a reasonable way, we want to rewrite them so they all have the same denominator. So what we really want to do is find a common multiple of 4, 5, and 10. And like I always say, we could use any common multiple, but it simplifies things a little bit if we use the smallest common multiple, or the least common multiple. And one way to find the least common multiple is take the largest of these numbers and look at their multiples and keep increasing the multiples until you find one that's divisible by the other two. So for example, I could start at 10. 10 is divisible by 5, but it's not divisible by 4. So then we can go to 20. 20 is divisible by both 5 and 4. So the least common multiple of 4, 5, and 10 is 20. So let's rewrite all of these fractions as something over 20. So let's start with 1/4. 1/4 is what over 20? Well, to go from 4 to 20, you have to multiply by 5. So you have to do that. You have to do the same thing to the numerator. You have to multiply it by 5. 1 times 5 is 5. 1 over 4 is the same thing as 5 over 20. 4 is 4 times 1. 20 is 4 times 5. Then we want to think about, well, what happens to 3/5 if I write it as something over 20? Well, to go in the denominator from 5 to 20, you have to multiply by 4. So you have to multiply the numerator by 4 as well. So 3 times 4 is going to be equal to 12. And then we're going to subtract 3/10. But how do we write that as something over 20? Well, to go from 10 to 20, you multiply the denominator by 2. So if we want to have the same fraction, we need to multiply the numerator by 2 as well. So 3 times 2 is 6. So what is this going to be equal to? Well, now I have 5 twentieths plus 12 twentieths minus 6 twentieths. So what is this going to be? Well, there's a bunch of ways you could think about it. You could say, well, this is going to be 5 twentieths plus 12 twentieths plus 12 twentieths minus 6 twentieths. Minus 6 twentieths, or another way of thinking about it, the way I just wrote it here, 5 plus 12 minus 6, all of that over 20. This is how many twentieths are going to result. So what does that equal to? Well, that's going to be equal to, all of this, we are counting twentieths is one way to think about it. So 5 plus 12 is 17, minus 6 is 11. So we get 11 twentieths. I have 5 twentieths, I add 12 twentieths, and I take away 6 twentieths, I'm going to be left with 11 twentieths. Let's do one more example of this, just for good practice. So here I have 4/9 minus 1/6 plus 1/3. And like before, I encourage you to pause the video and see if you can work this out. Well, what I want to do is I want to rewrite all of these fractions so that they have a common denominator. And to find a common denominator, I need to find a common multiple of 9, 6, and 3. And like I did before, what I could do is I could start with a 9 and say, okay, 9, it's not divisible by 6. It is divisible by 3, but that's not good enough. I want to find the common multiple of 9, 6, and 3, and as small as 1 as possible. So let's look at the next multiple of 9. We get to 18. And 18 is divisible by 9, of course, 6, and 3. So let's go with 18. Let's write everything as something over 18. So 4/9 is what over 18? Well, 9 times 2 is 18. That's what I did to the denominator. So I have to multiply the numerator by 2 as well. So this is going to be 8 over 18. Well, what's 1/6 over 18? Well, to go from 6 to 18 in the denominator, I have to multiply by 3. So I have to multiply the numerator by 3 as well. So 1 times 3 is 3. And then last but not least, what is 1/3 is something over 18? Well, 3 times 6 is 18, so 1 times 6 is going to be 6. Or you could view it another way. You could say, well, what's 1/3 of 18? It's going to be 6. What's 1/6 of 18? It's going to be 3. 4/9 of 18, that's a little bit harder to think in your brain, but that's going to be 8/18. Either way, I've just rewritten these fractions, and I've rewritten them in the corresponding color. So this up here is the exact same thing as 8/18 minus 3/18 plus 6/18. So what is this going to be equal to? It's going to be a certain number of 18ths. And so if I have 8/18 minus 3/18, that's going to be 5/18 plus 6/18 is going to be 11/18. And we are done. What we're going to do in this video is get a little bit of practice estimating dividing with decimals. So for example, we want to figure out approximately. That's what these kind of squiggly equal sign means. This means approximately equal. So what is 80 divided by 1.94 approximately equal? So we want to estimate what this is. So pause this video and see if you can figure it out. So before we even look at these choices, how would we try to do this in our head? Well, we could say 1.94, it's hard to do that in our head, to divide it into 80, but it's awfully close to 2. So we could say this is close to, this is approximately equal to 80 divided by 2, because once again, 1.94 is awfully close to 2, and then this is easy to figure out. That is going to be equal to 40. So our first expression, you could say, is approximately equal to 40. Is it exactly equal to 40? No, but it's pretty close. So I would select that choice. Let's do another one. So pause this video and see if you can figure out the approximation. What is 209 divided by 3 roughly equal to? So once again, here we don't have any clear decimals. If we were to divide it out, we would get a decimal answer for our quotient. But what we could do is, well, is either one of these, is for example, 209, is it close to a multiple of 3 that we might recognize? Well, you might immediately recognize that, well, if you think about multiples of 3, you think in terms of, well, 3 times 6 is 18, 3 times 7 is 21. Well, this is close to 210. So this is approximately equal to 210 divided by 3. Now, why is this interesting? Well, 210 is just 21 times 10. So if 21 divided by 3 is 7, 210 divided by 3 is going to be equal to 70. So once again, 209 is pretty close to 210. Remember, we're just estimating. And so 209 divided by 3 would approximately be equal to 70, which is that choice right over there. Let's do one more example. So once again, pause the video and figure out what 6.86 divided by 1.12 is approximately equal to. Alright, so here, I would just try to round to the nearest whole number and see if that helps my division in my head. So 6.86 is approximately 7 if we round up to the nearest whole number. And if I say 7 divided by, and if we round down 1.12, 7 divided by 1, this is much easier for us to do in our head. So that is going to be 7. Now once again, it's very important to realize these are estimations. It's not going to be exactly equal to 7, but it's definitely going to be much closer to 7 than 7,700 or 7,000.
Let's now get some practice estimating multiplying with decimals. So first here we have 7.8 times 307 is approximately equal to what? When you see the squiggly equal sign, that means approximately equal to what? So pause this video and see if you can figure it out on your own. Alright, so the way that I would think about doing it, even if I was trying to do this in my head at the supermarket or something, I'd say, well, okay, I probably need paper to do this properly, but gee, 7.8 is awfully close to 8, and 307 is pretty close to 300, so maybe I can estimate this by multiplying 8 times 300. Now this isn't going to be exact, it's definitely going to be off, but it's going to give me a good sense of roughly what 7.8 times 307 is. So what is 8 times 300? Well, 8 times 3 is 24, and so 8 times 300 would be 2400. We got these two more zeros, and so there you have it, and luckily the people who wrote this question estimated in a very similar way. Two people, when they estimate, might not get the exact same answer, but in this case we happen to. Let's do another example. So here, we're trying to estimate 99.87 times 19. So pause the video again and see if you can come up with a good estimation. Alright, so once again, not easy to do this in your head, but this 99 and 87 hundredths is pretty close. Let me do this in a new color. This is pretty close to 100 times, and I could multiply 100 times 19. That's actually not so difficult. So for example, I could say 100 times 19 is equal to 1900. But notice, we don't see that choice here. We could say, look, 1900 is definitely much closer to 2000 than any of these other. So that might be a good approximation. Now, how did they get 2000? Well, they rounded both of these numbers. They said this is approximately 100 times 20. So it's not that it's the right thing to do to round this 19 up to 20. If you could do 100 times 19, this is actually going to give you a slightly more accurate result than doing 100 times 20. But 100 times 20 is even easier to estimate in your head. But either way, the closest choice here, and that's why I guess these had to be multiple choice questions, is 2000. Let's do another example. So here, we are asked to multiply 2.21 times 5.1, and we want to know what it approximately equals. So once again, we are estimating. So pause this video and try to figure it out. Well, we're just going to do the same thing we did in the last two examples. 2.21, and well, first of all, this is hard to do in my head. And so 2.21, well, that's approximately, if I round to the nearest 2, or to the nearest 1, I should say, this is going to be 2 times 5, which is equal to 10. So this would be approximately equal to 10, and that is a choice. Now, some of you might say, well, there's ways to get better estimations that you could still do with your head. So, for example, you could say that this is pretty close to, this is approximately, let me do it over here. This is approximately equal to 2 times 5.1. This is still pretty straightforward to do in your head. This would be 10.2. And so, but you'd still say that this is by far the closest one. Or you could even say something like this is approximately equal to 2.2 times 5. What is this going to be equal to? Well, 2 times 5 is 10, and 2 tenths times 5 is another whole, and so this is going to be equal to 11. So all of these might be things that you could estimate that you might be able to do in your head, but the important thing to realize is however you do it, by far 10 is going to be the closest response to what you're getting at. And 10 would be a very natural estimation if you try to simplify both of these numbers when making that estimate.
My wife and I have recently purchased an assortment pack of soap, and we both want to experience all 3 bars, and we are not willing to share soap with each other. So we have a little bit of a conundrum. How do we share these 3 bars of soap so that we each get to experience all of the smells? So this might be a nice rose smell. This might be some type of, ivory smell. I don't even know if that's a legitimate smell. This might be some type of sandalwood, which is always very nice. And my wife has an idea. She says, look, I'm going to take these 3 bars, so we're starting with 3 bars of soap, and I'm going to divide it into 2 equal groups. And I said, how are you going to do that? And she says, well, I'm just going to take out some type of carving saw or carving knife or who knows what it is, and I'm just going to cut it right down the middle. So right down this. This is my wife cutting the soap right over here with her saw. So she's cutting the soap right over here. So she has divided the soap into 2 equal groups. So she has taken 3 bars and she's divided into 2 equal groups. So the interesting question here is, how many bars of soap do we each have now? And I encourage you to pause the video and think about that for a second. How many bars of soap do we each have now? Well, let's just visualize my share. Let's say I take this bottom half right over here. So this is Sal's share of the soap. Let me write this out. So this is Sal's share. My wife took this top half. Well, what do I have? Well, I have 1 half, I have another 1 half, and I have another 1 half of a bar. So I have 3 1/2s of bars of soap. Or you could say that I have 3 times 1/2, 3 times 1/2 bars of soap. Notice something very interesting happened here. 3 divided by 2 is equal to 3 times 1/2. And we could make it even more interesting because we know 2 is the exact same thing as 2 over 1. So 3 divided by 2 over 1 is equal to 3 times 1/2. Notice we went from a division to a multiplication and we took the reciprocal. And that makes complete sense. We have 3 half bars now. But what's 3 times 1/2? Well, 3 times 1/2 is equal to 3 halves. So just doing this little simple smelly soap example, we got a very interesting result. 3 divided by 2 is the same thing as 3 times 1/2, which is the same thing as 3 halves.
You have 2 fractions, 1/4 and 5/6, and you want to rewrite them so they have the same denominator and have whole number numerators. What numbers could you use for the denominator? So here's our fractions, 1/4 and 5/6, and we want to rewrite these fractions to have new denominators. So we currently have a 4 and a 6 as our denominator, and can we just pick any new thing, like maybe 5? Could we say, let's change them both to have 5 as the denominator? The answer is no. We have to pick a multiple of 4 and 6, a multiple, some number that we can multiply 4 and get this number as an answer. So for example, for 4, some multiples of 4 would be 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on. Those are multiples of 4. And let's just pause here and look at why we have to pick a multiple of 4 and 6. Why we can't just pick any number, but we have to pick a multiple of our denominators. So the fraction we were just talking about was 1/4. We could look at either one, but let's look at 1/4. Here we have a picture showing fourths. And to show 1/4, we shade one of these 4 equal size pieces. Well, maybe I want to change this and I want to say I want 2. I want 2 as my numerator. So to have a numerator of 2, I'm going to need to split this fourth up here into 2 pieces. Now I have 2 shaded pieces. So can I say this is 2, 1, 2 out of 1, 2, 3, 4, 5 pieces? It's not 2/5 because these are not equal size pieces. So if I split this fourth right here in half, I need to split all of them in half. And what I'm doing is doubling the amount of pieces. So now this is 2 pieces, this is 2, and this is 2 because we need equal size pieces. So now this is 1, 2 pieces out of 1, 2, 3, 4, 5, 6, 7, 8 equal size pieces. So 2/8. And you can see 8 is a multiple of 4 because we multiplied by 2. And that's what we did. We multiplied each of our pieces by 2. We also multiplied our numerator by 2 because that was also doubled. The amount of shaded pieces doubled when the entire amount of pieces doubled. And we don't have to do this just with 2. We could do any multiple of 4. For example, we can do one more here. If we, again, let's shade 1/4. One of the 4 pieces. And maybe this time we want to split it into 3 equal size pieces. So to have a new numerator of 3, and these should be equal sized, here's a numerator of 3, but we can't do our denominator yet because we don't have equal size pieces. So to get equal size pieces, we'll need to split each of these fourths into 3. So we are tripling the amount of pieces. So now we have 3 shaded pieces out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 12. And I could have figured that out without even counting because I knew that we tripled. This time we multiplied our original denominator times 3. We tripled. And we also multiplied our numerator times 3. So these are the multiples, 8, 12, and so on. And so those are the denominators we can pick. Something that we can multiply our denominator by, so we can multiply the entire amount of pieces. And again, so this is super clear, 1/4 and 2/8 and 3/12, they all represent the same amount. Whether we had 1/4 the original, here's 2/8, 3/12, they're all equivalent. They all represent the same amount. They're just different ways of writing the same number. Back to our original question, what denominators can we use for fourths and for sixths? Well, we know we need to use multiples, so let's look at the multiples. For 4, we've already gone through some of these. The first multiple of 4 is 4 times 1, which is 4. Second multiple of 4 is 8. 4 times 2 is 8, so we could split our fourths in half and get eighths. Or we could say 4 times 3 is 12, which we showed again, where we split our fourths, each fourth into 3 equal pieces. Or we could do 4 times 4, which is 16. 4 times 5 is 20. 4 times 6 is 24, and so on. The reason I'm stopping at 24 is I've looked at my answer choices, and I can see the largest possible answer is 24, so I don't need to write any larger multiples. There are many, many, many more multiples of 4, but we don't need to list them all because the largest number we're going to have to consider is 24. Let's do the same for 6. We could leave our 6 alone, 6 times 1, and keep 6 pieces, or we could double our 6. 6 times 2 would be 12. If we doubled the pieces, we would have 12 pieces. We could say 6 times 3, which is 18. Or 6 times 4, we could divide each of our 6 into 4 pieces, and we'd have 6 times 4, which is 24, or 24ths. And so on. Again, I'll stop at 24 since it's the largest number we need to consider. So down to our answer choices, what numbers could we use for the denominator? Could we use 8? Let's look at these lists. 8 is a multiple of 4, so we could definitely split fourths into 8s, but 8 is not a multiple of 6, so we cannot split 6 into 8s. So 8 will not work as a denominator for both fractions. How about 12? 12 we can see as a multiple of 4, and we showed that, we drew that already. And 12 is a multiple of 6. We could split our 6 into 2 equal pieces each, and we would have 12ths. So 12 does work. 12 is a denominator, a common denominator for fourths and sixths. 18 is here on the 6th. We could split 6 into 18 because 18 is a multiple of 6, but it is not a multiple of 4. So we can rule out 18. 18 is not a common denominator. And 24, you may remember, was the last number we wrote on both of them. So yes, 24 could be a denominator for fourths and sixths. So we could use either 12 or 24, and there's a lot more numbers we could use too as common denominators, but from these choices, we could use 12 or 24 as a common denominator for fourths and sixths. And just a note, lots of times people like to use the smallest one, the least common denominator, which in this case is 12. And it makes a lot of sense because it's easier to do computation with smaller numbers, but you don't absolutely have to use the smallest one. You could use 12ths or 24ths or lots of other options, but again, 12ths is probably the simplest one to work with just because generally it's easier to work with smaller numbers. But for this question, the common denominators we can use from these choices for fourths and sixths are 12 and 24.
So we have blank plus 1/16 is equal to 3 halves. So I encourage you to pause the video and figure out what blank is. What plus 1/16 is equal to 3 halves? Alright, now let's work through this together. Well, one thing that might make it a little bit simpler for our brains is if we were to express 1/16 and 3 halves with a common denominator. Well, when we think about a common denominator, we would look at a common multiple of the denominators here. And lucky for us, 16 is already divisible by 2. It's divisible by 16 as well, so it is the common multiple, or it is the least common multiple of 16 and 2. There are other common multiples, but the smallest one is going to be 16 times 1, which is also divisible by 2. So let's write both of these fractions. Let's rewrite this equation where both of these fractions have 16 as their denominators. This one obviously already has it. So let's write that. So we're going to have blank plus 1/16. 1/16 is equal to, let's see, let's write 3 halves as something over 16. Well, to get our denominator from 2 to 16, we have to multiply by 8. So we have to multiply the numerator by 8 as well. So 3 times 8 is going to be 24. Now at this point, you might be able to do it in your head. You'll say, okay, blank plus 1/16 is equal to 24/16. We could say, okay, we could view this as a certain number of sixteenths. So how many sixteenths plus 1/16 is going to be 24/16? Well, 23/16. I have 23/16, and I add one more 16th, I'm going to have 24/16. Another way that you could have thought about it, you could even have thought about it from the first step, is you could say, look, if blank plus 1/16 is equal to 3 halves, then you could say that blank is going to be equal to 3 halves minus 1/16. This is another way that you could have tackled it. If blank plus 1/16 is 3 halves, then blank is going to be equal to 3 halves minus 1/16. And we know that this is going to be equal to 3 halves, we already know is the same thing as 24/16. So 24/16 minus 1/16. Minus 1/16, which we figured out is 23/16, which is equal to, I'll just rewrite it again, 23/16. Let's do another example. So here, this is a little bit different. I have blank minus 3/4 is equal to 2/3. And there's a couple of ways to think about it. If blank minus 3/4 is equal to 2/3, that one way to think about it, you could say, well, blank, that means that blank is going to be the same thing as 2/3 plus 3/4. 2/3 plus 3/4 plus 3/4. And what is this going to be? Well, once again, I could rewrite both of these fractions so they have a common denominator. Well, what's the least common multiple of 3 and 4? Well, we could look at the multiples of 4 and keep increasing them until we find one that's perfectly divisible by 3. 4 isn't divisible by 3. 8 isn't divisible by 3. 12 is divisible by 3. In fact, it's 3 times 4 is 12. So we can rewrite both of these as something over 12. So this is going to be the same thing as... So to go from 3 to 12, we multiply by 4. So you have to multiply the numerator by 4 as well. So 2 times 4 is 8. 2/3 is the same thing as 8/12. So this is going to be equal to 8/12 plus... And then 3/4 is the same thing as what over 12? Well, to go from 4 to 12, you have to multiply by 3. So you have to multiply the numerator by 3 as well. 3 times 3 is 9. And what's that going to be equal to? So it's equal to this, which is equal to 8/12 plus 9/12 is going to be 8 plus 9 is 17. 17/12. So we get 17/12 minus 3/4 is equal to 2/3. Now, another way that you could have done it is you could have just kept it the same. You could have said, okay, let me just rewrite this. But I'm going to rewrite the fraction so that they have a common denominator. We already said, well, our common denominator we'd want to use is 12. At least that's the one we use. We could use 24 or something larger than that, but this would have been the least common multiple, so this keeps things a little bit simpler. And 3/4 we could have rewritten as 9/12. 9/12 is equal to, and 2/3 you could rewrite as 8/12. And you could assume that this is going to be a certain number of 12ths. So blank 12ths minus 9/12 is equal to 8/12. So if I have blank of something minus 9 of something, and I'm left with the 8 of that something, well, that means that I had 17 of that something to begin with. 17/12 minus 9/12 is equal to 8/12. But either way, you get 17/12 for our blank.
Let's say we wanted to figure out what 1/2 minus 1/3 is equal to. And we can visualize each of these fractions. 1/2 could look like that, where if I take a whole and if I divide it into 2 equal sections, one of those 2 equal sections would be a half, and you see that shaded in green here. And then from that, we're trying to subtract a third. And we can visualize a third this way. That if this whole thing is a whole, I divide it into 3 equal sections, and one of those 3 equal sections is a third. So what we want to do is take away this gray box from this green box and figure out how we can mathematically say what is left over. So pause this video and see if you can have a go at this. And I'll give you a hint. It will be useful to be able to represent your halves and thirds in terms of a different denominator. All right, now let's work through this together. So the way that we can approach this is to get a common denominator. If I can express both fractions in terms of the same denominator, that's going to be a lot easier to subtract. And the common denominator that's most useful is to find the least common denominator. And the smallest number that is both a multiple of 2 and 3 is actually 2 times 3, or 6. So what if we were to write each of these numbers in terms of sixths? So how can we rewrite 1/2 in terms of sixths? I always have trouble saying that. Well, if I start with 1/2, and if I multiply the denominator by 3, that's going to get us to sixths. And so I don't change the value of the fraction. I need to multiply the numerator by 3 as well. As long as I multiply both the numerator and the denominator by the same thing, well, then that's still going to be equal to 1/2. And you can visualize what that looks like. If you take each of these 2 equal sections and turn them into 3 equal sections, well, then you're going to have a total of 6 equal sections, or sixths, 2 times 3 in the denominator. And the part that was shaded in green, which was just one of those sections, is now 3 times as many sections. So your 1/2 is now equal to 3 over 6. And we can do the same thing over here. If we start with 1/3, how do we express it in terms of sixths? Well, to go from 3 to 6, I would multiply by 2. And so I also want to do that in the numerator so that I don't change the value of the fraction. And we can visualize that. Notice, if you take all 3 sections and you turn each of them into 2 sections, you now have 6 equal sections. So you are now dealing with sixths. And that 1 section before is now going to become 2 sections. So this is now going to be equal to 2 sixths. So we can actually rewrite things as this is the same thing as 3 sixths minus 2 sixths. And what do you think that is going to be? Well, if I have 3 of something and I subtract 2 of them away, I'm going to be left with 1 of that something. So I'm going to be left with 1/6 in this case. And we can visualize it just the way we visualized everything else. If you take 2 of these gray bars, or 2 of these sections from these 3 sections, you're just going to be left with 1 of them. This is 1 of the 6 equal sections.
What we're going to talk about in this video is the idea of a fraction. We'll see there's many ways to think about a fraction, but first we'll think about the most fundamental. So let's say that I have this square, and this is the whole, we can consider this a whole. So let me write that down. This is a whole. It is a complete square. Now what I'm going to do is divide this into 4 equal parts. So with one cut like that, I've divided it into 2 equal parts. And then with another cut like this, I could divide it into 4 equal parts. So there are 4 equal parts. And now what I'm going to do is I'm going to select one of those equal parts. So let's say this part right over here. I am going to select that. So the question is, what fraction of the whole is the part that I have shaded in red? Well, it is 1 out of the 4 equal parts, right? I've shaded in 1 out of 1, 2, 3, 4 equal parts. So we write this as this fraction. This piece represents 1/4 of the whole. And there's 2 ways that you can think about this. You could view this as 1 of the 4 equal parts, or you could view this as a whole divided by 4 would get you exactly this much. Now let's do another one, and this time let's think about how we could represent 1/8. So 1/8. Well, we could divide this whole, in this case the whole is this rectangle looking thing, we could divide the whole into 8 equal parts. So let's do that. So here I've divided into 2 equal parts. That looks pretty good. And now I can divide each of those into 2 equal parts to get me 4 equal parts. And then if I were to divide each of those into 2 equal parts, I will have 8 equal parts. And it's not exact, obviously I've drawn it by hand, but hopefully this gets you a sense. So now I have 8 equal parts, and now I'm going to select exactly one of them, and that'll represent 1/8. And I could select any one of these, but I'll just do this one to show you it does not have to be necessarily the first one. So once again, this square right over here that I'm shading in red represents 1/8 of the whole.
Now let's look at a few more examples where I've shaded them in ahead of time. And what I want you to do right now is pause the video and either in your head or on a piece of paper, write down, if you consider this purple thing the whole, what fraction does this red part represent? If you consider this blue part the whole, what fraction does this red part represent? If you view this yellow triangle as a whole, what fraction does this red part represent? And so I encourage you to pause the video now. Let's look at each of these. So in this case, for this rectangle, we have 3 equal parts, and we've shaded in one of them. So this red rectangle right over here, represents 1/3 of the whole. Now over here, in this kind of pie looking thing, this circle looking thing, we have 1, 2, 3, 4, 5 equal parts. 5 equal parts, and we have shaded in one of those 5 equal parts. So this little slice of the pie, this represents 1/5. This right over here is 1/5 of the entire fraction, or of the entire pie. Now this one's interesting. You might be tempted to say, well, I've got 4 parts, and then I've shaded in one. That must represent 1/4. But remember, it needs to be 4 equal parts. And it's pretty clear looking at this that this part right over here is not equal in size to this part right over here or this part right over here. These are not 4 equal parts. So we cannot say that this is 1/4 of the triangle. So you cannot say that.
You are likely already familiar with the relationship between multiplication and division. For example, we know that 3 times 6 is equal to 18. But another way to express that same relationship is to say, all right, if 3 times 6 is 18, then if I were to start with 18 and divide it by 3, that would be equal to 6. Or you could say something like this, that 18 divided by 6 is equal to 3. Now we're just going to extend this same relationship between multiplication and division to expressions that deal with fractions. So, for example, if I were to tell you that 1/4 divided by, and I'm going to color code it, divided by 2 is equal to 1/8, how could we express this relationship but using multiplication? Well, if 1/4 divided by 2 is equal to 1/8, that means that 1/8 times 2 is equal to 1/4. Let me write this down. Or I could write it like this. I could write that 1/4 is going to be equal to 1/8 times 2 times 2. And we could do another example. Let's say that I were to walk up to you on the street and I were to tell you that, hey, you, 42 is equal to 7 divided by 1/6. In the future, we will learn to compute things like this. But just based on what you see here, how could we express this same relationship between 42, 7, and 1/6, but express it with multiplication? Pause this video and think about that. Well, if 42 is equal to 7 divided by 1/6, that means that 42 times 1/6 is equal to 7. So let me write that down. This is the same relationship as saying that 42 times 1/6 is equal to 7. Now let's say I walk up to you on the street and I were to say, all right, I'm telling you that 1/4 divided by 6 is equal to some number that we will express as t. So can we rewrite this relationship between 1/4, 6, and t, but instead of using division, use multiplication? Pause this video and try to think about it. So if 1/4 divided by 6 is equal to t, based on all of the examples we've just seen, that means that if we were to take t times 6, we would get 1/4. So we could write it this way. T times 6 is going to be equal to 1/4. If this isn't making sense, I really want you to think about how this relationship is really just the same relationship we saw up here. The only new thing here is instead of always having whole numbers, we're having fractions and representing some of the numbers with letters. What we're going to do in this video is refresh our understanding of place value, but we're going to dig a little bit deeper and think about place value in the context of decimals. So just as a refresher, if I had the number 973, this should be review for you. We already know that this rightmost space right over here, this is the ones place. And if we move one space to the left of that, this is the tens place. Notice we went from ones to tens. Tens are 10 times as much as ones. And then we move one space to the left of that, we go to we multiply by tens again, we get to the hundreds space. And so this 9 doesn't just represent 9, it represents 900. Or we could write that as 900. Similarly, the 7 doesn't just represent 7, it represents 7 tens, or 70. This 3 represents 3 ones, so it actually does represent 3. But as I promised, we're now going to extend our understanding. And what we do is we put a decimal here, which you've probably seen before, at the right. And the reason why we even need a decimal is to really tell us where our ones place is. We say, oh, okay, if we go right to the left of the decimal, that's going to be our one space. Because once we start introducing decimals, we can introduce as many spaces as we want to the right of the decimal. And so let's think about those a little bit. When we went from hundreds to tens, notice, we divided by 10. When we go from tens to ones, notice you divide by 10. So what do you think this place over here is going to be called? Well, what happens if you take 1 divided by 10? Well, then you get a tenth. So, as you might imagine, this is the tenths place. And then if you were to go one place to the right of that, what would this place be? Well, it would be tenths divided by 10, or 1/10 of a tenth. So this would be a hundredths place. And then if you were to go one space to the right, and we could keep doing this forever, but if we were to go one space to the right of that, what would it be? Well, a hundredth divided by 10, or 1/10 of a hundredth, is a thousandth space. And so, for example, if I were to extend this number, instead of it just being 973, if I were to write 973.526, what do these numbers, these digits represent? This 5 doesn't just represent 5, it represents 5/10. Or another way of writing 5/10, you could write it like this, 0.5. You just have a 5 in the tenths place. Or you could write it as 5/10. This 2, and I think you get where this is going, this doesn't just represent 2, it represents 2 hundredths. I'm just going to make it very explicit in this video so it's very clear. 2 hundredths. Another way to write that is you just write a 2 in the hundredths place. So we're going 2 spaces to the right of the decimal, or you could write it as 2 over 100, 2 hundredths. And so, for kicks, pause the video. What are all the different ways of representing this 6? What does this 6 represent? Well, this is 6 thousandths. 6 thousandths. This thousandths. There you go. I could also write that as 0. Let's see, this is the tenths place, hundredths place, and then in the thousandths place, I have 6. Or I could write this as 6 over 1,000, 6 thousandths. So big picture, place value, we can keep going to the right of the decimal, and we can start representing things that are, I guess you could say, more precise.
We are told that 52 times 762 is equal to 39,624, and then we're told to match each expression to its product. And these products, this is an exercise on Khan Academy, you can move them around so the product can be matched to the appropriate expression. So pause this video and see if you can figure that out. Alright, now what you might have realized is all of these expressions deal with the same digits as 52 times 762, they just have the decimal in different places. And so what we can do is, we can say, hey look, the answer is going to have the digits 39624 in that order, and you can see all of these have the digits 39624 in that order, and then we can estimate what these expressions should be equal to, what the product should be equal to think about the decimal. So this first expression, 0.52 times 76.2, the way I think about it is 0.52, that's close to 50 hundredths, that's close to a half, and so 76.2, that's close to 76. And so this first expression, this first product, should be roughly half of 76. Half of 76 would be around 38. And so which of these is close to 38? Well, this first one is 39.624, so that's actually the closest to 38. The second one is 396, and then we have 3,962. So I like this first one, 39.624. That feels right. Now the second expression is 0.52 times 762. Well, once again, 0.52 is roughly equal to 50 hundredths, roughly equal to 5 tenths, roughly equal to 1/2. And 762, we could say, hey, that's, if we want to be really rough, really approximate it, we could say, hey, it's roughly 800. And so this should be about half of 800. So it should be around 400. And so we actually had that choice already there. So this would be 396.24. It definitely wouldn't be the 3,962.4. And so I'm already feeling good that this last choice sits down here. But I can verify it. 5.2, well, let's just say that's roughly 5. 762, let's say that's roughly 800. So 5 times 800, that would be 4,000. And so we would expect this expression to be close to 4,000, and indeed, that's what this choice is. So it turns out that it was already in the order that we needed to be, but it's good that we checked on that.
Let's say that we have the fraction 9 tenths, and I want to add to that the fraction 1/6. 1/6. What is this? What is this going to equal? So when you first look at this, you say, oh, wait, I have different denominators here. It's not obvious how I add these. And you'd be right, and the way to actually move forward is to find a common denominator, to convert both of these fractions into fractions that have a common denominator. So how do you think about a common denominator? Well, a common denominator is going to have to be a common multiple of these two denominators, of 10 and 6. So what's a common multiple of 10 and 6? And it's usually simplest to find the least common multiple, and a good way of doing that is start with the larger denominator here, 10, and say, okay, is 10 divisible by 6? No. Okay, no. Is 20 divisible by 6? No. Is 30 divisible by 6? Yes. 30 is divisible by 6. So I'm just going through the multiples of 10 and saying, well, what is the smallest multiple of 10 that is divisible by 6? And that's going to be 30. So I can rewrite both of these fractions as something over 30. So 9 over 10, how would I write that as something over 30? Well, I multiplied the denominator. I'm multiplying the denominator by 3. So I've just multiplied the denominator by 3. So if I don't want to change the value of the fraction, I have to do the same thing to the numerator. I have to multiply that by 3 as well. Because now I'm just multiplying the numerator by 3 and the denominator by 3, and that doesn't change the value of the fraction. So 9 times 3 is 27. So once again, 9 tenths and 27 thirtieths represent the same number. I've just written it now with the denominator of 30, and that's useful because I can also write 1/6 with the denominator of 30. Let's do that. So 1/6 is what over 30? And I encourage you to pause the video and try to think about it. So what did we do to go from 6 to 30? We had to multiply by 5. So if we multiply the denominator by 5, we have to multiply the numerator by 5 as well. So 1 times 5 is 5. So 9 tenths is the same thing as 27 thirtieths, and 1/6 is the same thing as 5 thirtieths. And now we can add. And it's fairly straightforward. We have a certain number of thirtieths added to another number of thirtieths. So 27 thirtieths plus 5 thirtieths, well, that's going to be 27. That's going to be 27 plus 5 plus 5 plus 5 thirtieths. Plus 5 thirtieths, which of course is going to be equal to, what is this, 32 thirtieths. 32 over 30. And if we want, we could try to reduce this fraction. We have a common factor of 32 and 30. They're both divisible by, they're both divisible by 2. So if we divide the numerator and the denominator by 2, numerator divided by 2 is 16. Denominator divided by 2 is 15. So this is the same thing as 16 fifteenths. And if I wanted to write this as a mixed number, 15 goes into 16 one time with the remainder 1. So this is the same thing as 1 and 1/15. Let's do another example. Let's say that we wanted to add 1/2 to 11 twelfths, to 11 over 12. And I encourage you to pause the video and see if you can work this out. Well, like we saw before, we want to find a common denominator. If these had the same denominator, we could just add them immediately, but we want to find a common denominator because right now they're not the same. Well, what we want to find is a common multiple of 2 and 12, and ideally we'll find the lowest common multiple of 2 and 12. And just like we did before, let's start with the larger of the two numbers, 12. And we could just say, well, 12 times 1 is 12, so that you could view that as the lowest multiple of 12. And is that divisible by 2? Yeah, sure, 12 is divisible by 2. So 12 is actually the least common multiple of 2 and 12. So we could write both of these fractions as something over 12. So 1/2 is what over 12? Well, to go from 2 to 12, you multiply by 6. So we'll also multiply the numerator by 6. And we see 1/2 and 6/12, these are the same thing. 1 is half of 2, 6 is half of 12. And how would we write 11 twelfths as something over 12? Well, it's already written as something over 12. 11 twelfths already has 12 in the denominator, so we don't have to change that. 11 twelfths, and now we're ready to add. So this is going to be equal to 6. This is going to be equal to 6 plus 11. 6 plus 11 over 12. Over 12. We have 6 twelfths plus 11 twelfths. It's going to be 6 plus 11 over 12, which is equal to, 6 plus 11 is 17 twelfths. If we want to write it as a mixed number, that is what? 12 goes into 17 one time with the remainder 5. So 1 and 5 over 12. Let's do one more of these. This is strangely fun. All right. Let's say that we wanted to add, we're going to add 3/4 to, we're going to add 3/4 to 1/5, to 1 over 5. What is this going to be? And once again, pause the video and see if you can work it out. Well, we have different denominators here, and we want to find this, we want to rewrite these so they have the same denominator, so we have to find a common multiple, ideally the least common multiple. So what's the least common multiple of 4 and 5? Well, we'll start with the larger number, and let's look at its multiples and keep increasing them until we get one that's divisible by 4. So 5 is not divisible by 4, 10 is not divisible by 4, or perfectly divisible by 4 is what we care about. 15 is not perfectly divisible by 4. 20 is divisible by 4. In fact, that is 5 times 4. That is 20. So what we could do is we could write both of these fractions as having 20 in the denominator, or 20 as a denominator. So we could write 3/4 as something over 20. So to go from 4 to 20 in the denominator, we multiplied by 5. So we also do that to the numerator. We multiplied 3 times 5 to get 15. All I did, to go from 4 to 20 multiplied by 5, so I have to do the same thing to the numerator. 3 times 5 is 15. 3/4 is the same thing as 15/20. And over here, 1/5, what is that over 20? Well, to go from 5 to 20, you have to multiply by 4, so I have to do the same thing in the numerator. I have to multiply this numerator times 4 to get 4/20. So now I've rewritten this, instead of 3/4 plus 1/5, it's now written as 15/20 plus 4/20. And what is that going to be? Well, that's going to be 15 plus 4 is 19/20. 19/20, and we're done.
We're asked to rewrite the following two fractions as fractions with a least common denominator. Least common denominator. So a least common denominator for two fractions is really just going to be the least common multiple of both of these denominators over here. And the value of doing that is then if you can make these a common denominator, then you can add the two fractions, and we'll see that in other videos. But first of all, let's just find the least common multiple. So the least common, let me write it out because sometimes LCD can mean other things. So least common denominator of these two things is going to be the same thing as the least common multiple of the two denominators over here. The least common multiple of 8 and 6. And a couple of ways to think about least common multiple. You literally could just take the multiples of 8 and 6 and see what their smallest common multiple is. So let's do it that way first. So multiples of 6 are 6, 12, 18, 24, 30, and I could keep going if we don't find any common multiples in this out of this group here with any of the multiples in 8. And the multiples of 8 are 8, 16, 24, it looks like we're done, and we can keep going obviously, 32, so on and so forth. But I found a common multiple, and this is their smallest common multiple. They have other common multiples, 48 and 72, and we can keep adding more and more multiples, but this is their smallest common multiple, their least common multiple. So it is 24. Another way that you could have found that least common multiple is you could have taken the prime factorization of 6. You say, hey, that's 2 and 3. So anything that is, the least common multiple has to have at least 1, 2, and 1, 3 in its prime factorization in order for it to be divisible by 6. And you could have said, what's the prime factorization of 8? It is 2 times 4, and 4 is 2 times 2. So in order to be divisible by 8, you have to have at least 3 2's in the prime factorization. So to be divisible by 6, you have to have a 2 times a 3. And then to be divisible by 8, you have to have at least 3 2's. We only have, or you have to have 2 times itself 3 times, I should say. Well, we have 1 2. Now let's throw in a couple more. So then you'll have another 2, and then another 2. So this part right over here makes it divisible by 8, and this part right over here makes it divisible by 6. If I take 2 times 2 times 2 times 3, that does give me 24. That gives me 24. So our least common multiple of 8 and 6, which is also the least common denominator of these two fractions, is going to be 24. So what we want to do is rewrite each of these fractions with 24 as the denominator. So I'll start with 2 over 8. And I want to write that as something over 24. I want to write that as something over 24. Well, to get the denominator to be 24, we have to multiply it by 3. 8 times 3 is 24. And so if we don't want to change the value of the fraction, we have to multiply the numerator and the denominator by the same thing. So let's multiply the numerator by 3 as well. 2 times 3 is 6. So 2 8s is the exact same thing as 6 24ths. To see that a little bit clearer, you say, look, if I have 2 8s, and if I multiply this times 3 over 3, that gives me 6 over 24. And this are the same fraction, because 3 over 3 is really just 1. It's 1 whole. So 2 8s is 6 24ths, and let's do the same thing with 5 6. 5 6. So 5 over 6 is equal to something over 24. Let me do that in a different color. I'll do it in blue. Something over 24. To get the denominator from 6 to 24, we have to multiply it by 4. So if we don't want to change the value of 5 6, we have to multiply the numerator and the denominator by the same thing. So let's multiply the numerator times 4. 5 times 4 is 20. 5 6 is the same thing as 20 24ths. So we're done. We've written 2 8s as 6 24ths, and we've written 5 6 as 20 24ths. If we wanted to add them now, we could literally just add 6 24ths to 20 24ths. And I'll leave you there because they didn't ask us to actually do that.
Let's see if we can figure out what 3/4 minus 5/8 is. And we have 3/4 depicted right over here. You could view this entire bar as a whole, and we see that it is divided into 4 equal sections, and that 3 of them are shaded in. So those 3 that are shaded in, those represent 3/4 of the whole. So you see that right over there. And then this bar down here, you could view this as another whole. This is another whole right over here, and you can see this divided into 8 equal pieces, and 5 of them are shaded in. So that represents the 5/8. So we want to have 3/4, this green shaded area, and we want to take away the 5/8. So how could we do it? I mean, when you look at it visually, it might jump out at you. Whenever we add or subtract fractions, we like to think in terms of having the same denominator. Are we going to deal in 4ths or 8ths or 16ths or whatever else? So let's think about having a common denominator. And a good common denominator is going to be a common multiple of the 2 denominators right over here, and ideally their least common multiple. And one way that I like to tackle that, there's many ways to do it, is look at the larger of the 2 denominators, look at 8, and then keep looking at increasing multiples of 8 until you find one that's also divisible by 4, perfectly divisible by 4. But with 8, you immediately say, well, 8 is divisible by 4, and it's clearly divisible by itself as well, so 8 is actually the least common multiple of 4 and 8. So you can rewrite both of these fractions as something over 8. So the 3/4, you can write it as something over 8, and then subtracting from that, the 5/8, if you want to write that as something over 8, well, that's just going to be 5/8. And then you can figure out your actual answer. So how can we rewrite 3/4 as something over 8? Well, there's a couple of ways to think about doing it. One way, look, I had 4 in the denominator, now I'm going to have twice as many equal sections. I multiplied by 2, so I'm going to have twice as many of the sections actually shaded in. So times 2, 3/4 is the same thing as 6/8. And we can also see that visually. If we're going to have twice as many equal sections, here we have everything in 4ths, but I'm going to turn this into twice as many equal sections, so I have 8ths. So let's do that. So you have this right here. Let me divide that. Let me divide that. Let me divide that. And then let me divide that. And now I went from 4ths to 8ths. I have 1, 2, 3, 4, 5, 6, 7, 8 equal sections. And we see that 6 of them are shaded in. That 3/4 is the same thing as 6/8. But regardless, now we can subtract. We have 6/8, and we want to take away 5 of the 8ths. So we have 6/8, and we want to take away 1, 2, 3, 4, 5 of them. And those 5 of them correspond to these purple 5 right over here. We're taking away 1, 2, 3, 4, 5. We're taking these away. So if you're just looking at the green, we started with 6/8. We're taking away 1, 2, 3, 4, 5 of them. That looks, and you can see that corresponds to the 5/8 down here. And what are you left with? Well, you're just going to be left with this 1/8 right over there. So it's just going to be 1/8. And you can see that numerically up here. If I have 6 of something, in this case it's 6/8, and I'm going to subtract 5 of that something, in this case 5/8, I'm going to be left with 1 of that something, or 1/8.
What we're going to do in this video is do a few examples ordering numbers that involve decimals. So let's say that we had the numbers 1.001, 0.113, and 1.101. What I would like you to do is order these numbers from least to greatest. Take out some paper and try to do it on your own before we do it together. All right, now let's do it together. And the way I would tackle ordering numbers is I would go to the largest place value that the numbers have in common. And so in this situation, we have a 1's place value in all of them. And so we can see that this has 1, 1, this has 0 1's, and this one has 1, 1. So the thing that has the least 1's is going to be the smallest of the numbers. So this one over here is going to be the smallest of the numbers. So let me just write that over here, 0.113. And now we have to figure out which one is next between 1.001 and 1.101. Well, then we just go to the next place value. So we go to the 10th place, and we see right over here, they're equal on the 1's place. So if you go to the 10th place, this one has 0 tenths, while this one has 1 tenth. So the number on the right here is going to be larger. It has more tenths. Same number of 1's, but it has more tenths. It doesn't really matter what happens to the right of that. So the next smallest number, if we're ordering from least to greatest, is going to be 1.001. And then last but not least would be this one. That is the largest, 1.101. Let's do another example. Let's say we had the numbers 0.424, 0.343, and 0.443. Pause this video and try to order these from least to greatest on your own. And once again, the idea here is always start with the largest place value and then compare and then keep moving to the right if some things are equal. All right, now let's do this together. So they all have 0 ones, so they're all equal there, so that's not going to tell us much. So now let's go to the tenths place. So here I have 4 tenths, here I have 3 tenths, here I have 4 tenths. So I don't even have to look at the hundredths or the thousandths place. This one has the least tenths. So I can put that as the least or the smallest of the 3 numbers, 0.343. And now, so I've already used that one. And so I need to compare these two numbers. They have the same number of ones, they have the same number of tenths. So then we move to the hundredths. So here I have 2 hundredths, here I have 4 hundredths. This one has less hundredths than this one. So the one on the left is going to be the next smallest number. So then we have 0.424. And then last but not least, this one right over here, it has the same number of ones as everything else. It has more tenths than this middle one and the same number of tenths as the left one. But then it also has more hundredths than the left one right over here. So this is the largest of the numbers, 0.443. And we're done. Let's compare 9.97 to 9.798. So to figure out which one of these is greater, I like to start with the largest place values and then keep moving to smaller and smaller ones until we actually see a difference. So they both have 9 ones. So at least in the ones place, they seem comparable to each other. Now let's go to the tenths place. So this number on the left has a 9 in the tenths place, while the number on the right has a 7 in the tenths place. So right now we could view this. Let's just write the whole numbers out. So this one is 9 plus 9 tenths. We haven't gone to the hundredths place yet. So far, out of the 2 digits, the 2 places we've looked at, this one on the right is 9 plus 7 tenths, plus 7 plus 7 tenths. So this immediately cues to me that the one on the left is a larger number. You're like, hey, how do I know immediately that's the larger number? I have all this other stuff to the right. I have this 9-8 to the right. I have this 7 to the right. And the way to think about it is, no matter what you have, even if you really increase this right-hand side here as much as possible, you're still less than 9.8. In fact, if you keep incrementing the thousandths here, you go from 9.798 to 9.799 to 9.8. So you would actually increase to get to even 9.8, and this is at 9.9. So you can really just look at the discrepancy in the largest place value to recognize which number is greater. This has 9 tenths, this has 7 tenths. It doesn't matter what's going on in the hundredths and the thousandths place. And to make that clear, let's actually add up these numbers and compare them as fractions. So let's keep on going with this. So you have 7 hundredths here, so you have 7 hundredths here, and here you have 9 hundredths. So here you have 9 hundredths. And then finally, here you have 0 thousandths, and here, let me do that in a different color. I already used blue. And here you have 8 thousandths. So plus 8 over 1,000. So let's put everything in terms of thousandths so that we can add these all up and have fractions have 2 fractions over thousandths, or things in terms of thousandths. So 9 is the same thing as 9,000 over 1,000. 9 tenths, well, let's see, if you multiplied it by 10, you would get 90 over 100. Multiply by 10 again, you get 900 thousandths. 7 hundredths multiplied by 10 is 70 thousandths. And let's do that over here. Once again, 9 is 9,000 over 1,000. And then plus 700 over 1,000. Plus 700 over 1,000, plus 90 over 1,000, plus 90 over 1,000. Just multiply the numerator and denominator by 10, plus 8 over 1,000 plus 8 over 1,000. And so what is this number on the left? This number on the left is, how many thousandths is it? It's 9,907. Sorry, 9,970. So it's 9,970 and 70 thousandths, while this number on the right here is, the number on the right here is 9,798 thousandths. So here, once again, you're comparing two numbers. They have the same number of thousands. This has 900. This only has 700. So even though this is almost 800, 800 is still less than 900. So no matter how you think about it, the number on the left is greater than the number on the right.
In this video, we're going to try to figure out what 1/2 plus 1/3 is equal to. And like always, I encourage you to pause this video and try to figure it out on your own. Alright, now let's work through this together. And it might be helpful to visualize 1/2 and 1/3. So this is a visualization of 1/2. If you view this entire bar as a whole, then we have shaded in half of it. And if you wanted to visualize 1/3, it looks like that. So you could view this as this half plus this gray third here. What is that going to be equal to? Now, one of the difficult things is we know how to add if we have the same denominator. So if we had a certain number of halves here and a certain number of halves here, well then we would know how many halves we have here. But here we're trying to add halves to thirds. So how do we do that? Well, we try to set up a common denominator. Now, what do we mean by a common denominator? Well, what if we could express this quantity and this quantity in terms of some other denominator? And a good way to think about it is there a multiple of 2 and 3? And it's simplest when you use the least common multiple. And the least common multiple of 2 and 3 is 6. So can we express 1/2 in terms of sixths? And can we express 1/3 in terms of sixths? So let me just start with 1 over 2, and I made this little fraction bar a little bit longer because you'll see why in a second. Well, if I want to express it in terms of sixths, to go from halves to 6, I would have to multiply the denominator by 3. But if I want to multiply the denominator by 3 and not change the value of the fraction, I have to multiply the numerator by 3 as well. And to see why that makes sense, think about this. So this, what we have in green, is exactly what we had before, but now by applying the numerator and the denominator by 3, I've expressed it into sixths. So notice, I have 6 times as many divisions of the whole bar, and the green part, which you could view as the numerator, I now have 3 times as many. So these are now sixths. So I now have 3 sixths instead of 1/2. So this is the same thing as 3 over 6. And I want to add that, or if I want to add this to what? Well, how do I express 1/3 in terms of sixths? Well, the way that I could do that, it's 1 over 3. I would want to take each of these thirds and make them into 2 sections. So to go from thirds to 6, I'd multiply the denominator by 2, but I'd also be multiplying the numerator by 2. And to see why that makes sense, notice, this shaded in gray part is exactly what we have here, but now we took each of these sections and we made them into 2 sections. So you multiply the numerator and the denominator by 2. Instead of 3 equal sections, we now have 6 equal sections. That's what the denominator times 2 did. Instead of shading in just one of them, I now have shaded in 2 of them, because that one thing that I shaded has now turned into 2 sections. And that's what multiplying the numerator by 2 does. And so this is the same thing as 3 sixths plus, this is going to be 2 sixths. Then you can see it here. This is 1/6, 2 sixths. And now that everything is in terms of sixths, what is it going to be? Well, it's going to be a certain number of sixths. If I have 3 of something plus 2 of that something, well, it's going to be 5 of that something. In this case, the something is sixths. So it's going to be 5 sixths. I have trouble saying that. And you can visualize it right over here. This is 3 of the sixths, 1, 2, 3, plus 2 of the sixths. 1, 2 gets us to 5 sixths. But you could also view it as this green part was the original half, and this gray part was the original 1/3. But to be able to compute it, we expressed both of them in terms of sixths.